Dear participants, glad to hear from you, glad to see you. Welcome back. Today is our second day of the Young Scientist Forum, and today we have scientific session on panel discussion, and our session is artificial intelligence. We have 5 presentations, each of 12 minutes. You are to hear from the presenter and prepare your questions in raise your hand chat mode. After the presentation, we will have a time for only one question answer. And after the 5 presentation, we will have 15 minutes for the discussions regarding all the presentations. Right? And the first presenter is from Brazil. Please, Leonardo Bacelar Lima Santos. 12 minutes. Let's start. Dear friends, our technicians prompted me that the presenter from Brazil didn't connect. So we go further, and the next presenter is Denis Ponomarev, Russia. The floor is yours, please. 12 minutes.
Okay, hi everyone, I'm Denis from the city of Novosibirsk, which is located in the middle of the country. It's third most populous in Russia and known as the capital or center of Siberian district of Russia and one of the largest research centers. Well, it's known for Novosibirsk State University, which is number 3 in the country. There are over 40 research institutes around in various fields. And there are many IT companies, which some of them reside in the Novosibirsk Technopark. In this talk, I'm going to talk about AI research in Novosibirsk, which has a parallel tradition from around 60s. Can you maybe guess who is this person with big hair here? So actually, it's John Macari. And at the end of 60s, he had a research stay at Novosibirsk Scientific Center. And around 10 years before that, he has come up with the notion of AI, basically. So, and since that time, there has been a lot of research in AI in Novosibirsk. In this slide, I list some of the very hot topics nowadays. And in particular, in this my talk, I will talk about fusion of symbolic and sub-symbolic methods, which is a very hot topic nowadays. Obviously, there has been a lot of progress in AI recently with the field of computer vision, which is analogous to the ability of human seeing, or speech recognition, which is analogous to hearing, or speech synthesis, robotic motion control. And these fields are sometimes addressed as data-driven intelligence. That is, you try to generalize from the data, you're trying to make conclusions, hypotheses from that, make predictions. But then the question is, where is thinking in this picture? Where is reasoning? Where is arguing? Where is planning? And the other large subfield of AI is the knowledge-driven intelligence, where you want to make conclusions, to generalize, to reason about knowledge. And probably many of you have seen such adversarial examples for neural networks, where you have a bunch of pictures that you train on, then you make some corruption in them, not seen to human, but you get radically, drastically different conclusions after these corruptions. Or maybe if there's a picture and you want to reason, you have a bunch of questions, you want to answer these questions about the picture. These tests obviously require some reasoning, and this trend is very hot nowadays. So if you look at AAAI keynotes, then all the 3 big guys in neural networks say that knowledge should be incorporated into neural-based models in some way. So some say that reasoning should be a part of neural networks, for instance, logical reasoning. And actually can express anything. You should be able to express anything by neural networks. But then I ask myself, do I want a neural network to do arithmetic for me? For instance, compute the simplest operation over integers. I personally wouldn't do that. If I want to do some arithmetic, I would use some basic calculator for that. And if I want to incorporate it into a neural network, I would do that. And basically, this idea extends to combining the neural-based world of AI and the knowledge-based world of AI, and in order to benefit from the both worlds. So we are developing approaches which benefit from knowledge-based approach, because the problem with many neural-based models that you need to encode the knowledge about your subject domain in your neural network or in other methods. Then you make predictions with your model, you get a result, but in order to explain it, you need to decode. You need to decode from vector space, for instance, or you need to do some cumbersome things to explain your results. This is a well-known issue. So in our approach, we make no encoding. Actually, we take a model of a subject domain, and we use it in our prediction model. We get the results, and we do not need to do anything for decoding. We get an explanation in terms of the semantic model. Well, these are ingredients of our approach, but I want to explain it just in a simple example of cancer diagnosis, like traditional fields where you may want to make predictions. And in this domain, you have some concepts which relate to cancer diagnosis and to analysis of features that relate to cancer, right? And you want to represent it in some way. And there is a hypothesis. And there is a hypothesis editor which allows you to write down hypotheses, the form of hypothesis that you want to discover in the data. You want to specify the way they look like, the language of hypothesis, in concepts of your domain model. Then you train, and our method allows for inferring rules from data by using logical probabilistic inference. In order to make predictions, you apply the rules to data to be analyzed. For instance, patient data, you get a result. For instance, that some patient is certain to have adenoma, and you get rules responsible for this prediction, and you are able basically to obtain explanation right from these rules, like natural language explanation for that. Well, and our approach lies to discovering complex regularities on data, which other methods are unable to find. For instance, first-order dependencies with for all and exist quantifiers. And well, this is just an example from foundational domain. You may say, yeah, that's a kind of toy example. But actually, we apply the same approach for adaptive motion control of robots. So the modular robotics is a hot topic nowadays, where robots are composed of modules. Well, you can compose them, and you want to give them some tasks that they should do. For instance, move in certain directions or grab some things. And this field is a kind of complicated. So there are lots of problems in there. So like automated locomotion, like supporting reconfigurations, and there are obviously many degrees of freedom. Well, in our approach, we use actually the same idea of incorporating domain knowledge, and we use reinforcement learning. Our approach allows for hierarchical goals and hierarchical planning, which, for instance, neural approaches are not yet able to cope with. So we are able to generate sub-goals automatically. Their learning speed is rather high, doesn't require a lot of data. And if you want to do sensing, this is a place for neural networks. For instance, if our robot wants to see something, this is the place where we plug in the neural network. So at this point, I want to show you some video which shows this is a modular robot consisting of 6 equal modules, and it is given a task to move into one direction. So now it learns how to move. So first it makes some spontaneous movements of each module, but then it learns how to make these movements simultaneously with each module. And then gradually it becomes to move into one direction. So still it learns, it's still learning at this point, but then it starts moving. It starts reaching its goal. For instance, in this picture, in this particular experiment, the goal was to reach to the to move to the right. Okay, and we applied the same principle to simulating the behavior of real-world organisms. So I stopped the video for a moment. This is a worm, C. elegans, the nematoda worm. And this is a computer model of this worm, which we developed in the Ural Institute of Informatics Systems. And we applied the same learning techniques to this model. So actually the task was for this model to learn how to move in a liquid, in some liquid, well, substance, right? And actually, we were very surprised to see that this way of learning has well, has made it possible to move just similarly or equally like this organism is moving in the natural world. So basically, the movements that have been learned are equal to the movements of the real organism or the real one. So this, in this picture, by the red, those parts of the worm are activated, which corresponds to the muscles in this movement. Okay. And there are some papers on that. So basically, you can follow them if you like. I hope the slides will be available after my presentations. Well, and if you're interested in any of these research topics, I don't have time to speak about all of them. I just wanted to show you some very, very hot research which is happening now at the research center. But if you have interested, then you're very welcome to join. There are several possibilities. First of all, you may want to apply for a research grant, and the deadline for that is November 15th, so rather soon. You may check out this webpage if you like. If you're interested in study programs, then there is a lot of possibilities at Novosibirsk State University. You can check out these bachelor, master, and PhD degree programs. This year we have held a very, very great workshop, which was held obviously online, with over 200 participants from all over the world. And we plan to make this workshop again next year. So you may check it out, how it was this year, and plan your schedule for the next year. And we regularly post announcements of postdoc positions. So once again, you may follow one of these web pages, or if you have some question, you may drop me a line. So that's basically it. And I'm very happy to get any questions. Thank you.
Thank you for the interesting presentation. Do we have a question? We have a time for one question. I do not see the proposition.
Hello?
Maybe...
Hello?
Hello? Please, one short question.
Hi, Denise.
Hi.
I really enjoyed your presentation. I would like to know, how is your topic related to software robotics? I mean, biological inspired robotics.
Okay, thank you. Well, this demonstration with the C. elegans is most related to the topic you mentioned, because the model is a living organism, so it exists in the real world. And actually, there are two directions. So in this experiment that I showed you, we have used our approach to teach this living organism how to move. And it was surprising to see that the learned movements were actually the same like in the real world, but they could have actually not occurred. That was just an interesting result of this experiment. Another direction in this research is to learn from the nature, how the organisms live, how they move, and so on, and try to implement it in the artificial models, right? And actually, the very basic idea behind our approach of learning with these probabilistic rules is borrowed from natural observations. So, for instance, the principle of entropy and actually the Occam razor, if you like. So it's observed in many ways of optimizing things in real life. So I don't have time to speak much now, but we do both directions.
Right. Thank you very much. But let me remind that we will have 15 minutes for the discussion around all the presentation. And our next presentation is from Brazil. by Sandra Elisa Fontes de Avila. Please, stage is yours. Please share your presentation at the screen. Right.
That's right?
Yes, that's okay. We can see
Okay.
your presentation.
Okay, nice.
Please, you may start.
Okay. Hi, I'm Sandra Avila. I am a professor in the Institute of Computing at the University of Campinas in Brazil. I'm very happy to be here. Thank you all again for this opportunity. I do research on machine learning and computer vision for healthcare, sensitive content analysis, and precision agriculture. For those applications, our team is actively researching on deep learning with images and videos. And today I'm going to talk about our results and problems on deep learning for healthcare, in particular for skin cancer analysis. So why do you care? Why do you care about skin cancer? Skin cancer is by far the most common of all cancers. In Brazil, it accounts for 33% of all diagnosed cancers. The good news is that the melanoma, the most dangerous type of skin cancer, is detected early. And the chance of survival is 97%. So early detection saves lives. The standard method for the examination of skin lesions is based on pattern recognition. So we can say, hello, machine learning. You can be used to increase the chance of successful treatment. But let's move on, but keep this number, the 97%, in mind, please. Our research lab, Record Reason for Complex Data, has worked on melanoma classification since 2014. Our team is responsible for remarkable results associated with deep learning and skin cancer, not only in Brazil, but in the world. In 2017, we were ranked first place for melanoma classification in the challenge Skin Lesion Analysis Towards Melanoma Detection, promoted by the ISIC, the International Skin Image Collaboration. And at that time, we aggressively optimized our model and especially our data. After the challenge, we decided to investigate methodological issues for design and evaluating deep learning model for skin lesion analysis. For example, I have a list here. The use of translearning, model architecture, training data set, image resolution, type of data augmentation, input normalization, use of segmentation, duration of training, test data augmentation. And our results, not surprisingly, show that the amount of trained data has a huge influence, explaining 46%, this is a surprise, of the variation in performance. So we have a problem, the same problem that everybody have. We know that data collection, we need data. We know that data collection and annotation are expensive, time consuming, and difficult to obtain. So our idea to bypass this problem is to generate realistic synthetic skin lesion images. So for that, we use GANs. GANs are the generative adversarial networks. And GANs are being used today for forge beautiful arts and to refine deep fakes. I think everybody knows what is deep fake. But for skin lesions, we have a problem. It's not possible, not yet, but it's not possible to generate real image, realistic images. So our first images are like that. I think you can see some examples. But in 2018, instead of generating the image from noise, the usual way with GANs, we decided to explore image translation. So we model the skin lesion scenario into semantic and instance map. So the left side, we have the maps, and in the right side, we have the image. So the idea is to translate the maps to the image. So the GANs learn how to do that. And now we have really realistic synthetic images. It's not possible to distinguish real from fake here. It's not only my opinion, it's the opinion of the physicians also. You can check out our paper, the images about the skin lesions are really beautiful. So you train a skin lesion classification network with synthetic and real images. The real image is still important, and we are able to improve our performance models. But the problem, all the time we have a problem, is that our skin lesion was so good that we start think about bias in deep learning models, bias in data sets. So if the bias is present even in bigger and more diverse data sets like ImageNet has 1 million images, it's naive to think that it's not present in the smaller and hard to obtain skin cancer data sets. So data set bias may inflate the performance of our models. And this bias, the bias came from the dark corners, for example, the image at the top, mark inch, gel bubbles, color charts, the image at the bottom, and roller marks, skin hair. And the question is it possible to be completely bias-free? And we know that it's too hard. We are trying to do that, but it's not possible yet. But if we destroy the important information in the data, so we try to do that. It's not possible to remove the bias, but we would like to experiment to destroy the important information. For example, lesions. So we'd like to classify skin lesions without lesions. Okay. Here, it's important to know that for melanoma, a simple way to remember the warning signs is the ABCD rule. A stands for asymmetrical, one half of the lesion doesn't match the other. B stands for border, is the border irregular? C is color, is it uniform? In that case, it's non-uniform. And D is for diameter, is the lesion larger than 6 millimeters? So we gradually destroy meaningful information, the important information in the data, and measure the performance of our models. So we employ two of the most important skin lesion data sets, the Interactive Atlas of Dermoscopy, ATLAS, and the International Skin Image Collaboration, the ISIC. And since both data sets are publicly available, most of the recent work in skin lesions rely on these data sets. So if you find some problems here, probably a lot of works have problems analyzing those, using those data sets. Here for the next experiment, you use only real images, okay? So we split our experiment in 4 data sets, in 4 setups. The first one is the traditional. The traditional is the data set, the usual information used for training and evaluating skin lesion analysis networks. The image contains all pixels informations, and we expected to have the highest score in our test, being our upbound baseline. The only skin, so you create this data set, we take advantage of segmentation mask as the second line. We remove the pixel information, they turn black inside the actual lesions. So about the ABC rule, we remove the C, the lesion color information. The next one is the bound box, the B box. And here we try to destroy the lesion board. So we cover the silhouette of the lesion with a black bound box. And now we have only health skin and their effects. And the last one, the worst scenario is the bound box 70, BB box 70. And here we try to destroy the lesion, the size of the lesion. The size of the lesion is really important. And we define that every bound box must at least cover 7% of the pixels. And at this point, there is no information left to apply any of the factors from the ABCD rule. Okay. So surprisingly, it's a real surprise that the network can make sense of visual features to make decisions that are much better than chance. So you can look at our traditional results is the best one, and we expect that it's with the whole information. But the worst scenario, the BBPOC 70, there's almost no information about that, and the result is 71%. We have 3 experiments, the training with only one data, and across data set, we train with the ISIC and evaluate in the Atlas data set. It's a hard experiment. And just to add, the AUC achieved by the methodologists for demoscope images in these data sets, in the ISIC especially, is 67%. And the idea here is not to compare the machine versus AI, or the machine versus humans. And the idea is to question what is happening to these data sets, what happened to these networks, what the network is learning here. We don't have this answer, sorry. Not yet. This researcher won the best paper award in the CVPR, the ISIC workshop last year, 2019. We are very happy, we're very excited that our research has been published on newspapers and communicated on TV news in Brazil. Also, for 4 consecutive years, from 2016 to 2019, we won the Google Latin America Research Awards. And we hope our research may lead to insights to increase the chance of early detection in skin lesion analysis. But let's back to the number that I asked you to keep in mind in the beginning of the presentation. For Black people, the survival rate is 67%. And machine learning here, not only, but here, has the potential to save thousands of people from skin cancer each year, while putting others at great risk. So my message here is that our driven solution should be inclusive, and we are responsible for that. So we have to think about what we are doing with our machine learning models and our data. So my students, and thank you.
Thank you so much for the prominent presentation. We have a bit of time for one question only, please, if you have a question.
Hi, Sandra.
Hi.
This is Dennis. May I ask a short question? Can you say something about the accuracy of the predictions obtained? Are they only from visual data or from some additional kind of data?
It's Julie only visual data here. We already tried using like the information about age and sex, but it's not working. We don't have a lot of data. So we don't input this information on our models. You would like to do that, but you don't have.
And what about accuracy?
Sorry, about the accuracy is over 90%.
Okay, great.
Okay.
And just add a comment, and we input the synthetic image, we can improve our model by 1 to 3%, the accuracy.
Thank you very much for the answer. And our next presenter is from India. Please, Nishant Kumar. 12 minutes and stage is yours. Please share your... Oh, okay. We can see your presentation.
Okay. Hello everyone, I am Nishant Kumar. I am from India, and my research area is mainly in the area of energy. So I will present my work. Mainly it is based on the artificial intelligence based control technique for optimal use of solar energy generation system. Means what are the issues now coming going on with the solar energy generation system. So mainly I have tried to sort out that problem. So today's all discussions I will mainly discuss two type of problem. What the key challenges what I have shortlisted. So mainly the power generation system is look like this. What I shown in this figure means the sun will provides the power energy and we converts by using the photovoltaic panel and uses for load as well as extra power we feed to the main grid or we can say the national grid. So these are the basic common things for the solar power generation system. But the key challenges is here. So this sun will be available only for the 8 hour. 8 hour means morning 8 to evening 5 p.m. Means this type of system mainly works for only 8 to 9 hours. So the question is, what is the use of the entire circuit in the night time, or we can say the in 24 hour, 8 hour this system will work, but 16 hour, what is the use of this system? This system is not a easy or not a simple one. So when you will see in the nighttime duration is around 5 p.m. to morning 7 a.m. means around 15 to 16 hours, means 2/3 of the every day the system will not in use. Also, I have shown here the entire circuit. When you will go in detail of the circuits, then you will see the circuit is very complicated, which consists of two converters, a big capacitors, filters, as well as inductors and the filters. But these all are very expensive circuit as well as totally unused during the night time. So the question is how we can use is this circuit for some other purpose. Definitely in night time sun will not available, but the question is maybe some other purpose we can use this circuit or not. So in my research, first of all, I tried to use this circuit in the night time by using the artificial intelligence based control. Also, you can see here that this entire circuit is useless during the night time. In night time, directly power comes from the national grid and goes to the load. Whatever load we have directly come from the grid and go to that. But this entire circuit will useless for the 16-hour daily. So I have tried to resolve these issues. So for that purpose, I have developed a AI-based control technique, and in this control technique, I have used this portion of this solar circuit in night time for reactive power generation. Means for reactive power generations require two type of things. One is converter and another is our capacitor. These two are enough to generate the reactive power. So in night time, I have used this circuit for reactive power generations because sun is not available, so it will not use. And we know that all the household loads are mainly AC. AC means two things: active power and reactive power. So in night time, active power will come through directly from the grid, but reactive power will come through this circuit. And this circuit will fit to the reactive power requirement of the load and this active from the grid. So what will happen in night time? At least reactive power stress on the national grid will decrease. So for that purpose, mainly I have tried to resolve this issue by using the artificial intelligence based control, because here control is most important thing, because control will only decide when this circuit will work as a solar integrated circuit or behaves like a night mode as a reactive power generation system. So this entire things will decided by the artificial intelligence based control technique. So for that purpose, here I have developed a ANOVA kernel list mean square algorithm based artificial neural network control technique. So here, what is the use of this entire neural network is? So here this network estimates two things. One is active and reactive power requirement of the load. Another one is grid synchronization behavior for unit template by using the unit template concept. So for that purpose, one control I developed. So here challenge is, in general, in offline training means you are estimating or you are planning. Artificial intelligence, it's very useful and very easy to use because you have no time bound. But in this circuit, time bound is very important because here we are operating converter which are running on an atmospheric pulse, on which speed is in kilowatt, in kilo range. So here a single layer neuron I have developed, which will also run with processor on that high speed. So for that purpose, this ANOVA kernel list mean square I have developed. So which also synchronize with the processor speed and also estimates according to that. So this is the whole block diagram what I have developed. And what I have developed that I have tested on the experimental setup. This is my experimental setup in the lab where I have tested this entire operations. So in this results also you can see in the daytime the PV power is there, voltage and current is there, means PV power is coming. But automatically in the night time when it is zero, so system automatically restores for a reactive power generation. So you can see here, this is the reactive power generation in the night time, same circuit. Similarly, in the night to day mode, means in the early morning, how system restores from one mode to another mode according to the situations. So these things I have tried to resolve by using the artificial intelligence based control technique. So also here you can see night to day mode, means the early time morning also. Also, I have tested this system in the grid unbalanced conditions. Suppose our national grid is faulty, then how my artificial intelligence will estimates and works according to that. So I have shown here, one load has gone zero, no load is here, but still system is stable and working fine. Similarly, over voltage conditions means here voltage has increases, then how current automatically balancing. No need to extract effort here. So system will automatically estimates and works according to that. Under voltage conditions also. Similarly, here the grid under the imbalance conditions. See here, the voltage is totally imbalanced. One voltage is higher, the other is too less, but current is totally balanced. So in system will automatically restoring and performing according to the requirement of that. Here 32% unbalance I have considered for testing of this algorithm what I have developed. So I can conclude that so in night time also we can use this system for partially reactive power generations, so that in night time at least grid stress on the grid will reduce. So other issues what I have tried to solve here, partial shading conditions in the panel. What is partial shading conditions? Means that if any shadow will become on the PV panel, shadow due to anything, shadow due to the building or tree, whatever. So and that situations our characteristics deteriorates, means comes with the multiple peaks. So in these situations, how we will track the power? So in this situation, power tracking is the very important thing. So also you can see in the practical setups here the shading is there, means two shading is on the same panel. Similarly, in the solar power electrical train, here you can see the shading will come when it will run, shading will on the panel. Similarly, in the electric vehicles also the shading issues will come. Similarly, like this snow will come on the panel, then issues will be there. Also in the desert area, you will see the how the shadings comes due to the dust. Also in the rover also, NASA is also facing the same type of issue on the Mars mission. So for that purpose, I have tried to solve by using this human psychology optimization technique. This technique is totally based on the psychology of human psychology, which based on the four factors: excitement, self-motivation, inspiration, and relation. So by using these factors, human behavior factors, I have derived these equations, and this is my final equation. In these equations you can see so how the four factors I have used, and then finally four factor uses for update the particles during the searching. And also one new things I have given here. So no, in next iterations, no, all populations will not go for the searching. So everywhere 1/3 populations will replace by using the chromosomes concept. Chromosomes means here the mutation, heuristic mutations process I have used for generations of new chromosomes for the new searching area. So these concepts mainly I have developed for solve these partial shading conditions. Partial shading means multiple peaks due to the shading. So how the system will work. Also I have tested on that systems. So here tracking time I have taken for 0.48 second, and as I know, so NASA has given the challenge over this. The challenge was 1 second. They have given the challenge 1 second. Within the 1 second, you track that. So I have tried to resolve this by using the human psychology optimization technique. Also, I've shown the one animation here how iterations goes and how the particles moves and concentrates on the peak like this. Also, on the experimental setups, I have taken 0.51 second, means only 51% time for the searching and rest 49% time on the efficiency. And the efficiency is the very important thing when you are working on the rovers on the Mars. Then you will see efficiency is very important. So here I have shown the efficiency, experimental efficiency, 99.98, 99.97, and here this is 99.99% efficiency on the rovers. So these are my whole trajectory of the searching. So how the particles moves here and there and converges. So these two issues I have tried to solve by using this neural network and optimization concepts. One for the solar uses in the night time, another one for the shading conditions. When the shading is on the panel, then how we can extract the power from shading situations. So like that. So finally, I can conclude that. So here AI-based technique or optimization-based techniques are highly suitable for resolve this issue, because now in every country, everywhere, the solar we are using for power generations, but definitely the solar only 8 hours. So rest 16 hours at least we can use this type of concept for reactive power generation in the night time. Also shading condition, because now we are moving towards the electric vehicles. Definitely vehicles are coming, then battery issues will come. So better to go with the solar powered electric vehicle. So definitely when vehicle will run, then shading will come, then how we will search. So these issues are the very recent issues what I have found. So on that basis, I have published a few papers, what I've shown here. I have published around 20 IEEE transactions. In different IEEE transactions I have published, and total I have 27 journals I have published, which including 20 transactions, and as well as 5 patents I have filed. So these patents are running. So these patents are also related to the same, the shading conditions as well as the power instruction. So how the system works in these operations. Thank you. Thank you for your kind attentions, and I am happy to collaborate if anyone interested in this area. So we can think about that. Thank you.
Thank you for the prominent presentation. We have a bit of time for the one short question, please, if you have. No question, maybe one short question from me. So do I understand correctly that the commercialization of all your research is right now in the progress?
Yeah. Yes, I am under process, because patents I have filed. So very soon I hope the patents will approved, and then we can go for the prototyping. Prototyping is already, lab prototype is already completed, but now on the commercial level, we are side by side we are going for that. But first of all, we are trying to complete the this task. I mean patent task. Then we will go for the electrical side.
Thank you. Our technicians prompted me that we have one more question, but sorry, I should retain this very question till the discussion after all the presentations. Well, our next presentation is from China. Please, Zhang Yu Wang, 12 minutes, and stage is yours. Please, we cannot hear from you. Your microphone. Hello, yes.
Hello, can you hear? Okay. Can you hear?
Just to be on the safe side, please close all the messengers at your screen, if you do have. We lost your presentation. Okay.
Can you hear
Very
me?
good. Yeah.
Okay. Thank you. Hello. It is a great honor to have the opportunity to speak on this forum. I'm Wang Zhenyu from Northdac Company, and I am also a PhD candidate of Fudan University. Compared with other speakers on this forum, I may be the one who is least like a scientist. This may be because I am firstly is an entrepreneur, and I'm also a PhD student in social science. And whether social science is a science or not may be still a controversial issue. So my brief presentation of our company's main product and service, Social Code, may be helpful to discuss this interesting question. First, let me briefly introduce the background of our team. We provide AI products and technical solutions for the complex decision and the digital transformation of research institutes, such as Chinese Academy of Social Science, Peking University, and Fudan University. The origin of our idea is inspired by one of the founders of artificial intelligence, Herbert Simon, who is a genius in interdisciplinary research. He hoped to solve the human's decision-making behavior through algorithms. This is also the core idea of the main school of artificial intelligence study, the symbolist school, whose the principles are mainly the hypothesis of physical symbol and bounded rationality. Simon's research inspired us to re-understand the relations between social science and decision-making. We can regard decision-making as a modeling and a computation of external social systems. Fortunately, since Nazar and other 15 scholars publish live on the internet, the era of computing society in science, the rise and the development of computing social science has provided us with rich R&D toolboxes. Computational social science regards social system as the organization of information processing and conducts comprehensive interdisciplinary research on social system through computational methods such as simulation, modeling, network analysis, and quasi-experiment. In fact, from the perspective of knowledge production and contribution, the research of social science is essentially to obtain the mechanisms and the factors to explain of complex social events. Through the combination of these answers, we can predict or change these social causal chains. But the problem is that before there was a toolbox of computational social sciences, the traditional research paradigm was basically a single discipline, one-time project-based research whose outcome are mainly the publications. But such a research paradigm is difficult to accumulate and difficult to commercialize, especially in the face of the complex decision-making, such as the multi-factors, the multi-context, the cross-influence. The most important issue is that traditional research is actually similar to a single-time consulting project. But for repeated decision-making scenarios, the theoretical results of a single research cannot be reapplied, let alone the effective accumulation of data and upgrade iterations. A series of similar commercial attempts have been made to transform social sciences theories into these big data solutions, such as the typical application are SAP for business decision-making and Palantir for political decision-making. After studying these business models, we came to the conclusion that we can split overall decision-making process into 4 steps. The first step is to assure our requirements, and the second step is environmental assessment, and the third is strategy formulation, and the last is execution. And in this regard, we can establish a service framework including 4 parts. They are strategic consultation, and module customization, platform assembly, and intelligent decision making. To this end, we have established a technical system consisting of more than 30 patents. First, natural language processing is used to solve problems ranging from demand scenarios to algorithm conditions. And the second, through the massive data fusion technology, we can analyze some social science problems into the computational models, such as the analysis of economic indicators based on the image cognition. And finally, we model important classic social decision-making scenarios to help complex decisions. We use this most cutting-edge social science scenarios, theories, and appropriate artificial intelligence technology to evaluate the environment and provide different sets of strategies. Next, I will briefly introduce our specific products. First is our computational social science research platform, which can serve the scholars in social science. In fact, for social science scholars, how to choose to develop a project that uses emerging technologies is an important and complex decision. We will first help researchers to find cutting-edge issues, so we made trend analysis around subject keywords and embed key papers into it, which consolidates our research information database. And secondly, we use tree structure and academic social network model to visualize to the scholars to evaluate the theoretical development and find optimum cooperation models in this field, which can help them assess the value, the direction, and the feasibility of their study. Secondly, we have established an open collaboration platform to help scholars to find their best projects and supporters in their study area. Finally, we provide a series of classic models to help scholars use new methods to solve important and recurring social science problems. For example, assessing public opinions under the impact of the incidents, and accurately assessing the economic performance of a specific area. The second product that serves international political and legal issues. We cooperate with the team of State Key Laboratory of Pattern Recognition of the Chinese Academy of Sciences to establish a technical solution for the international political and legal system. We also regard these problems as complex decision-making problems. Its scenario requirements can be clearly defined. That is, how to choose the best compliance processing strategy. In the part of the environment assessment, the biggest problem of this kind of political and legal service is how to deal with the laws and the regulations of different states, which have different cultures, different judicial systems. We pay special attention to the policies and laws of the countries along the Belt and Road, because this is not only the focus of our Chinese investment, but also has important research value. The complex language and the political environment of these countries also make related legal issues more difficult, but it also will make our system smarter. On the other hand, we use the neural network translation platform to establish the political and legal database of the countries along the Belt and Road, so that our products can serve the legal translation tasks of different countries. Secondly, we have established an interactive system to assess the legal stuff based on past cases and machine processing for these related legal issues. If it meets the constituent elements of classical judicial case, our system will automatically generate relevant answers. If our system cannot understand or handle this problem, it will be transferred to legal staff for further operation. In addition to above these products, we have also developed derived products based on political risks and financial forecasts. It is worth mentioning that the differences between us and some AI company maybe we are actually theory-oriented rather than data-oriented. As a famous sociologist Max Weber said in the methodology of social science, he said that social outcomes are naturally a multi-cause and a multi-influence event. So therefore, for complex decision-making scenarios in social science, such as policy making, there may be unexpected situations where the more data but the worst effect of machine learning. So because once the temporal and the spatial scenario change, the trained model is prone to be overfitting. So we believe that the best solution is to conduct algorithms based on important social science theories, which involved in classic decision-making scenarios. And therefore, we established such interdisciplinary team and cooperated with Chinese top social science research institutions. Well, finally, I want to end with the motto of our company. We believe that in the era of artificial intelligence, human deserves better decisions. The combination of social science and artificial intelligence will undoubtedly explode with infinite possibilities. Okay, thank you. Thank you for your kind attention, and I am welcome to the questions. Thank you.
Okay, thank you very much for the prominent presentation. Dear friends, I should announce the final presenter without any question because we are very tight in the time frame. So the last presentation before the coffee break should be from South Africa. Please, Tiboga Lucky Memela. 12 minutes. Stage is yours.
Hello, everyone. I don't know if you can see my screen.
Please share. Oh, okay. We can see your presentation.
Hello, everyone. First of all, thank you for this opportunity for me to give this project titled as Artificial Intelligence for Biological Inspired Soft Robotics. So my name is Debu Kholaki Mamela, and I'm from the University of Johannesburg in South Africa. The content of this presentation will be as follows. First, I'll begin with the introduction, and followed by the state of the art, followed by the sensors, actuators, the key technologies, and some development trends, and then lastly will be the conclusion. So the figures on the left shows the first untethered robot, which is figure 1, which was developed by Harvard University of Engineering and Applied Sciences. Figure 2 shows the first Octobot, which is entirely soft and autonomous, which was also developed by Harvard University. So, why am I doing this presentation today? So we all know that traditional rigid robots are not very safe to interact with. Therefore, there is a need for people to interact with robotics, but they have to be soft and human friendly. So soft robotics is the specific subfield of robotics that makes robots which are highly compliant with the use of highly compliant materials, which are flexible, and they are actually inspired by living organisms. So intelligent soft materials include soft polymers and elastomers, which are elastic and very stretchable. So they can also be fluid or gels. So soft robotic technologies have also introduced paradigms in the design and development of soft robots. Therefore, artificial intelligence has also improved the modeling and the kinematics of the soft robotics. So with the use of neural networks to provide new learning-based approaches for modeling, control, and design of soft robotics, we have improved a lot of soft robots in terms of how they handle or how they move or how they uh, uh, change dimensions, spaces. So with the use of AI algorithms, also the robots can figure out the next actions. So based on Danny's presentation, also we can use reinforcement learning with the use of trial and error for soft robots to be able to learn, and we can figure out what it's going to do next or mimic a certain behavior. So here is a conception of a future AI soft robot, which is an octopus. Uh, we can have it as a geometrically enabled fluidic or biohybrid. So as we can see here, uh, they have different kinds of sensors and they have different kinds of actuation, which I will discuss in the next stage. But most of the actuation is based on uh, different kinds of materials that are used. Some can use piezoelectric materials, some use shape memory alloys, and some can use CNT or other different kinds of smart or intelligent materials. So the state of the art, muscular hydrostats such as elephant trunks, mammals, uh, lizard tongues have actually inspired the design of flexible and uh, soft robotics which are able to bend and extend and twist. So the biological muscles, they play a very important role in the aspiration of artificial intelligence soft robotics. So this artificial intelligence soft robotics uses machine learning strategies to accurately mimic the movements of the real activity of the robot, which is supported and assisted by the virtual world in with a digital twin. So this means that you would have a soft robotic hand on the side, and you would have a digital twin on the side of which the soft robotic hand will mimic according to the behavior of the soft robotic of the hand. So when it is given an objective, then depth sensing cameras will create a digital copy of the object. So we use reinforcement learning to adopt for trial and error techniques. So soft robotic is inspired by the prominent capabilities of soft biological structures where hard robots have evolved to imitate soft structures and soft robots that adopt the use of electroactive polymers or pneumatic artificial muscles. So the principle of sensing for soft robotics in terms of compliance and morphing has mostly been used by the conventional types of sensors, which include encoders, metals, or semiconductors, strain gauges, or initial measurement units. However, uh, there is a design by Rail Truby, which is shown in Figure 7A, where they have a flexible sensor, which uses a Kirigami-based design and fabrication method to create soft and pressure-resistive strain sensors. So the figure on the bottom, figure B, shows an artificial intelligence model that can tell deformable robots how their bodies are positioned in a 3D environment. So the basis of proprioceptive sensors for an AI soft robot is usually either non-contact sensors or very low modulus elastomers combined with liquid phase materials. So deep neural networks are built for heavy lifting, and by shifting through the nodes to the noise to capture meaningful feedback signals to estimate the IS of robots configuration using sensors. So this leads to the reduction of the thickness of the stiff materials and to arrange them in elastically deformable structures for deterministic and ultra thin structures. So that's how we achieve the high degrees of freedom movement by the soft robotics. So figure 8 shows the soft robotic octopus gripper that has also a high degrees of freedom. Uh, Models have been developed to kinematically describe the soft robot shape that vastly reduces the numbers of variables which are needed for their model to process. Figure 9 also shows the soft robotic fingers that leak water when the temperature rises. So they're actually actuated by different kinds of temperatures. So actuators. So we all know that pneumatic and hydraulic actuators are the most highly adopted techniques in soft robotics. Therefore, there have been several developments in the application of pneumatic actuators, which include robotic locomotion, grasping, robotic, haptic, and assistive devices which can be used by elderly people. So another actuation method is light actuation, which is adopted to induce a direct environmental response in an actuator, such as light or sun or any radiation in an biometric iris. So figure 10 shows the artificial muscle which expands under a electric current. So it is actuated by an electric current, and uh, Figure 11 shows the artificial carbon nanotubes, which are non-polymetric micromolecular structures. So they have GMT, which is a graphite monoatomic. So soft robotics are usually actuated by different kinds of methods, which can also include tension cables or pneumatic, as tension can be hydraulic. However, we have fluidic elastomers actuators, which are also new type of highly extensible and adaptable low power soft actuators. They look like springs, as shown in figure 12 below. They comprise of synthetic elastomers, which are operated by the expansion. So, what are the key technologies in soft robotics? So we have to have materials, the design, and the modeling. So with the materials, as we've mentioned before, they demand soft and flexible materials which can withstand high level of deformation for their realization. And as for the design, um, we have to have design approaches which can allow the soft robot to be within the boundaries of desired softness and load bearing capabilities that should be recognized. As for modeling, we have to model the manipulators which can accommodate large deformation constitutive models of the active smart materials that form the manipulator with a nonlinear kinematic of the manipulator. So here are some of the developmental trends in soft robotics. As you can see, we have a twistable artificial muscle that is actuated by either electricity, and we have a newly developed electrical actuated device also uh, looks like a plastic, and we have a soft hand, which is twisted string actuator scheme, where it's made low cost and simple and lightweight. And we have figure 18 shows an AI robotic gripper, which is used in many industries that can actually interact with human beings. So here is the design and the modeling of soft robotics. So given that finite element analysis is computationally heavy and does not land itself well in real-time control and modeling techniques, they are applied on top of kinematic analysis to learn the input and output relationship through nonlinear regression. So we use Abacus and MATLABs for computational capabilities, and then we can use then artificial neural networks to train and to present the robot in specific relationships in between loads and constant curvature parameters. So figure 19 shows the design and the kinematic modeling framework of a soft robot modules. So also this adds to the modeling where you have neural network and sensors that capture subtle motions and dynamic movements. However, it is therefore important to embed learning-based approaches to sub-robotic control so that you can increase the degrees of freedom and the locomotion and the kinematics also. So humans are not precise machines compared to our rigid robotic counterparts. However, intelligent soft robotic manipulators are also kinematically similar to hyper-redundant manipulators, which are extremely large DF. So in conclusion, as we continue towards the practical untethered systems improvements in artificial intelligence for soft robotics, robustness, sensitivity, strength, and efficiency, it then becomes increasingly important to use these methods of neural networks for locomotion, control, and modeling. Therefore, the need for AI in soft robots prevails as this project seeks the optimal solution towards actuation, sensing, and control, as well as total integration of soft robotics with artificial intelligence. Therefore, this investigation of intelligent material and mechanical design from the conception of AI soft robots is the key importance for further research amongst the BRICS nations. Therefore, the technology and research development towards the mentioned soft robot components will not only advance the AI robotics community, but will also advance the neuroprosthetics, the material sciences and engineering, the chemical engineering, computer sciences, and medical studies. These are some of the references that we can use, that I've used also for this research. You can check them out as well. Thank you very much for you listening.
Thank you
These are
so
my
much.
contact details.
Yeah, thank you so much for the interesting presentation, dear participants. So we do have 5 minutes for the discussion around all the presentations. Please raise your hands and technicians will get the floor for you. We'll
Okay. So
Денис
may I have,
Пономарев, пожалуйста, please.
yeah, thank you. Thank you. May I have a short question to the last presentation? Just maybe I missed it from your talk, but do you also produce parts of these robot architectures? Do you produce components for that?
Actually, I'm working on a research on soft robotics, um, design and modeling for soft robotics. I'm working with Shanghai University in China to develop an untethered soft robotic hand. So we use different kinds of material, as mentioned. We use polymers, shape memory polymers. We also use elastomers. So we also use 3D printing to print maybe the whole structure of the robot, and then we can then configure using machine learning for the robot as to for the movements of the robot, maybe to imitate or maybe to mimic different behaviors that we want for the robot or for the robotic hand to do. So we're still on initial phase in terms of development, sir.
Mm-hmm. Oh, I see. Thank you very much for the interesting talk.
Thank you
Thank you.
very much.
Any more
Dennis.
questions? Any more questions? Any more feedback?
For Prof. Sandra,
Please.
I just wanted the second speaker. I wanted to ask if how her skin lesion classification works on different skin colors, if that's part of the data set or what her experience is with that.
In fact, this was the question for the first speaker, right? Skin cancer. Sandra Elisa Fontes de Avila. Okay. Please, could you please answer, Sandra?
Okay, I'm not allowed to unmute my microphone. Now it's okay. The problem for the different skin colors is that the data sets are collected from rich hospitals, and so all the models are trained in the skin colors of white people. So we don't have data from something different about that. So, and it's more important because it's not about data. The discussion doesn't exist. So we have to discuss that. We have to think about that, to collect the data, because the models, it's not possible to work if the models are training on the skin color of white people. So I don't know how the models work on those data sets, because I don't have the data. I never studied about that, but I know that the partners are different, so probably it not work. Okay.
Thank you for
Thank you for
the
the question.
answer, dear participants. It was the last question in this session before the coffee break. We should interrupt. See it after the 50 minutes. Dear participants, welcome back. We continue scientific panel on artificial intelligence. And the first presentation is from Brazil. Welcome, Leonardo Basilar Lima Santos. Please, 12 minutes. Stage is yours.
Hi, thank you. So I'm Leonardo Santos, I'm from Brazil, and I will talk about mathematical sciences for disaster risk reduction. Um, First of all, I do thank you to Brazilian and Russian committees for this opportunity, and also I thank you all for coming to this talk. I will first I will introduce myself and talk about my background. So I will talk a little bit about my scientific production, show some of my papers, and finally I will summarize my scientific initiatives and some ideas for joint projects. I'm a physicist, and I got my PhD in applied computing in 2014. 2 years later, I invited to be a professor in INPE, the Brazilian National Institute for Space Research. And now I have my group of students with undergrad, master students, PhD candidates, and postdocs. In São José dos Campos, last year, I was in Berlin as a visiting professor at Humboldt University. I was working on uncertainties for paths in complex networks, but I will not talk about here. I will talk about machine learning itself. The SEMAREN was created in 2011. It's a young institution in Brazil, and we work on under a multidisciplinary approach. We in meteorology, hydrology, social sciences, mathematical sciences. Many others. Now I am much more interested in data-driven models than in physical models. So it's a paper we have already submitted, but it's not accepted yet, about rainfall nowcasting. Nowcasting is a short forecast, okay? And we use a deep learning, LSTM artificial neural network, and we had a very radar data, a meteorological radar data, a remote sense as input layer, and our goal was to forecast where it's raining and how much it's raining. So in this paper, I already published it. Have done a community detection and clustering analysis in high-resolution meteorological networks with about 1 kilometer in space in 1 hour in time. It's very interesting to realize, to know picture is much more related to length user and length cover than to the digital elevation model of the region. So, very nice finding. And in this paper, we developed a neural forecasting model. I mean, a forecast model based on an artificial neural network. The input data was rainfall and river level for some specific points in the space. And our goal was to predict water level in this lowest point here. We had some very results. The Nash Sutcliffe index was above 0.9. It's a very good result. And now I'm working on a comparison who will be the winner between an artificial neural network critical curves and physical based model and Twitter data. Our goal is to predict, to forecast urban floods in the city of very nice database with more than 15 years of data. We have data about each with impact on transportation system in the city of São Paulo. We are now finishing the paper presenting this database, and we will share it with publicly. Our idea is to forecast it using different approaches. Each one of them with this specific advantages and disadvantages. And the idea is to work under a sustainable development goals approach. Okay, we are talking about smart cities, climate action, several climate sustainable development goals. And talking about impacts of this book chapter, a very theoretical work, but a very nice one, I think, about interface between machine learning, complex networks, and survivability analysis under a disaster risk reduction point of view. I'm also one of the editors of this book, this one, already published by Spring in Nature. And okay, now I will talk about my scientific initiatives. I think it's very important. I'm the head of a group called Mathematics for Disaster Risk Reduction, held on the Brazilian Society for Computational and Applied Mathematics, the SBMAC, created in 2010. I'm young, but there are a lot of senior researchers in this group. For example, the Ministry of Science in Brazil between 2012 and 2014, Professor Marco Antonio Hauck, and in 2017, we organized the International Workshop on Mathematics of Climate Change and Natural Disasters here in São José dos Campos. It was a very nice event with funded by FAPESP and Newton Fund. As several other researchers, we are trying to collaborate somehow for COVID-19 studies. In those papers, in the first one, we used a mobility complex network between cities. I mean, the number of people that goes from one city to another one in some tiny window, and we compared those data with the emergence of coronavirus cases in Brazil, in Brazilian cities. So it was a diagnostic paper. And in this one, we asked ourselves about control. So we realized a robustness analysis on traditional approach for complex network using those data. We had some very interesting results, and we have just submitted a proposal to this multilateral project with BRICS, okay, COVID-19, integrated multi-scale spread models and control strategies. We have colleagues from China, from Russia, and several institutions in Brazil, okay? So we have an artificial intelligence dedicated we have data for sharing, we have methods, we have already tested some of them, and the most important, we have people. We really would like to establish new collaborations, to work on together in some very specific problems. So why not we organize a virtual by international internship for our students last summer that is ending right now, right today. I was the for some students from India. It was a very nice experience. So I think we could organize something like that, maybe. And making a wish, it would be great to find out someday a call for young researchers, bringing together teams with research from different BRICS countries. It would be great. Thank you very much for your attention. That's my email. Feel free to get in contact.
Thank you so much for the interesting presentation. We have a time for one short question. Please raise your hands in the chat. Dear participants, we do have a time for the question. Are you tired or not? Please. Okay. Maybe one question from me. What is the what would be the first project for the collaboration regarding your wish at the last slide?
Okay, this one. Yeah.
Number one.
I think, sorry?
The project number one for the collaboration.
Sorry, with project?
Please open the slide regarding your wish to collaborate and to establish a team of young researchers, and what would be the project number one for such a team?
Okay, yes, absolutely. For example, in this, for this call, it was a very nice one. Sure, I do appreciate it, but it's for general researchers. In this slide, I'd like to register it for the organizers about a call specifically for younger researchers. We have several of them here in this audience, working on different projects, different teams. I know it, but I think there are a lot of interesting points for the different countries. For example, climate change. It's a global interest, and we can relate several different techniques, data, and personal experience on that.
Right, very good. Thank you for the answer. We can go further. Our next presenter is from Russia. Please, Sergei Sorokin, 12 minutes. Stage is yours.
Thank you. I hope you can hear me.
Yeah.
Just a minute.
Please share your presentation.
Yep. Okay. Can everybody see it?
Yeah, fine.
It's okay? Okay.
Yep.
Thank you. My name is Sergei. I am from Russia. I am from Penza City. I live currently in Penza, and I'm working at Penza State University. And just a brief introduction. Where is it, Penza? It's not far away from Moscow. Russia is a very big country, and I hope one day every participant from abroad, from Brazil, India, China, South Africa, will have a chance to visit Russia. And of course, I will be really glad if we can organize some event in Penza city. Just a brief introduction about myself. I got my PhD from Penza State University, and I was really happy to have been working as a visiting researcher in Hong Kong University of Science and Technologies many times before this pandemic. This really had helped me a lot with my research, with my English, with my career, and I hope we have time to talk about it later during my presentation. Of course, AI is really popular now, and we are currently working I mean, all of us on different projects. And I just would like to underline that, in my opinion, it's a great future. I mean AI. Let me just mention what is so special about AI. Of course, we are on the right track. Almost everywhere we're using AI. I mean, in medicine and education, in military, in every spheres, and it's worth to mention that AI specialists, I mean, these specialists can get a very high-paid job, and in my opinion, it's a key issue about AI. You can do a lot of things, and you don't have to thinking about how you can get additional kind of money. There are a lot of applications about AI, databases, AI, text understanding, image processing, and so on. A lot of applications, and of course, image processing is just one of them of this application. And what's more, even in image processing, we can find different spheres like image recognition, educational purpose. For example, if we can help students to pass, to check if they are a real person in front of the camera or if it's not a real person. In medicine, using preliminary image processing, we can also apply a lot of things from AI. And again, it's also only just one of things. It's about image recognition. Let me tell you a little bit why faces. I had my PhD about preliminary image processing. We are working on things like using different kind of filters for noise removal, image enhancement, segmentation, and so on. But it's an interesting story when we discuss with my colleagues from Hong Kong University of Science and Technology what we can do together and how we can publish a good paper together. And it just was an idea, how about if we can find some topic with faces? Everyone has a mobile phone, and it's really popular nowadays to take pictures, but more, we have to add, not only take pictures, we can add some masks on faces, we can distort faces, and we can post immediately what we have on our phone. And that's why it was just an idea. How about if we think a little bit about privacy? It's a key issue. For example, let's say we are on the street and we would like to take a picture about ourselves, but how about other people who are just behind us, or they just happen to be in our frame? Actually, it's a big question now, especially in Europe and other countries. We have to ask nowadays the permission to use their faces, and we just got an idea. How about if we, for example, find a way we can slightly replace faces if we are not sure if a person will give us his concern or won't give us his concern. How about we can find a way to use this picture without his consent? Just an example. For example, if we have some picture from public life, and that will need to worry about. But let's say I'm in a restaurant and I would like to take a picture of myself, and I live in my town, but the guy or girl next to me, they don't want to give their permission. Maybe he with his girlfriend, and at home he has a wife. It's just one of the possible cases. That's why, let me mention, we are just in the middle of our research. We hope to publish everything by the end of this year, if everything is okay. And how about we train our network to slightly distort faces and distort it so way that we can see the whole picture. And later, of course, later it will help us to later we can use other things like changing of clothes and some things, but it is our first task. I mean, how can we change faces? It's not a simple task. Let me remind you. Simple distortion is not a suitable idea. Key issue in our project, we would like to save emotion expressions on the face. It's really important. We can't just simply remove or delete faces from picture or replace one face with another face. It's not our main task. We would like to train our networks in order to it will help us to not only recognize emotions, but to save the whole atmosphere with the face. With one key issue, this person couldn't later recognize himself, and he wouldn't be able to claim his right on this picture. It was our main. It is our main goal in our project. And of course, it's other questions for discussions, and I'm really happy I can raise it here. For example, is it possible to tag a person on the photo? And another things, we don't have any kind of one regulations in every country. For example, in Russia we have one kind of rules, and Europe or in US we have another kind of rules. And how we can solve it together, find a suitable solution. Let's say next time when you take a photo, actually you can allow your apps find out where you are. Let's say you are in Russia, you don't have to follow this rule. But if you are in another country, you have to kind of follow it.
Please be concise. You have 1 minute. One more.
Yep, thank you. And another things, let's say if a person has changed his mind. Yesterday I was sure I gave you permission, but today I changed my mind and I'm not able to give you my permission. It's another question. But I hope anyway together we can solve everything. Again, it's my pleasure to share our research with you. I didn't go too much into detail, but I hope during our forum we can discuss further. Thank you very much for your attention. I am looking forward to taking your questions. Thank you.
Thank you very much for the interesting presentation. Hope through the video we saw your real face. Maybe someone have questions.
Thank you.
Please raise your hands. Not any questions. Maybe one short question from me. So what about the commercialize of this idea? How do you find this? So is it possible to commercialize this topic?
Thank you.
Just an example.
Before this idea, we already think we thought about this kind of commercialization, and I think we can see a good possibility. Let's say we have official law in one country, and our algorithm and interpretation will simplify the way to the market, because everyone would like to use it in order to do not violate any regulations. Our idea.
And of course, for the husbands who cheat their wives. Okay, thank you very much.
Thank you.
Thank you very much. Our next presenter is from India. Please, Rahul Kataria, you have 12 minutes. The stage is yours.
Yes. Uh, Very good evening and good afternoon to all. Title of my today's presentation is the just a second. These are what are the challenges you will see in healthcare analytics using AI, mostly in BRICS countries. So I have done some survey, you can say, because I will not focus on the algorithm part and the techniques part. So I made this PPT as much as you can say easier for everyone. I am Dr. Rahul Kataria, Associate Professor in Department of CSC, Delhi Technological University, New Delhi, India. And before I start, I will say hello to, according to your places, Ola in Brazil, Privet in Russia, and Namaste from India, and you can say Ni Hao in China, and I will use the word Seguana if I'm not wrong in the jury. So love you all. You are my all my friends. Definitely after my presentation, we will discuss in which area we can do work. So now I'm moving. So this is my profile. I'm working as associate professor in Department of CSC, and also working as an official in charge in international partnership and visitation in my university in the Office of International Affairs. Recently, in January 2020, in this year, I was invited as a young officer and a researcher under the framework of Japan and Asia program of Sakura Science in Japan, Tokyo. The theme was almost same in the artificial intelligence, and I'm working in the area of AI, big data analytics, computational intelligence, healthcare analytics, climate change, and disaster management. I have various groups. They are working in these areas, and I have publications around 60, and I'm working in the university, which is a you can say the top 10 university in India. So as you can see, my university comes sometimes fifth on various parameters, seventh, and sometimes on ninth in India. Very old university, and our mission, as far as research is concerned, I am not dictating in the going in the algorithm part and the you can say other techniques of AI and all. Just I am dictating with the generalized form. So one point, the first point that I'm focusing on the transformational force in healthcare, how we can change, how can we analyze the people behavior, daily routine, and other factors so that we can make our life as much as simple. And another approach we are focusing on that how we will get the precise information from various data sources. We have collaboration with various hospitals. Recently, we submitted BRICS project with the South Africa and the Brazil that was recently launched related to the COVID-19. Another approach, we are also focusing on the medical devices monitoring of various, you can say, the patients with various diseases. We are also focusing on how to reduce the diagnosis and how to apply various, you can say, the wearable devices. We are also working on some wearable devices. So this is a drone that was mine in my university. What do you see as a AI point of view, how we can collaborate? So first of all, the first thing that always uh, we should give a priority is we should make a friendly relationship with the global security of population. So we are from various different zones, but we have to work on one problem that is, you can say, for the human benefit. So we can apply various techniques, where technology. I will not list down because that particular list, you can say, is very long. We can make a, you can say, make a very good relationship in the sense of the trade and investment, and definitely we can collaborate in the sense of various, you can say, research labs. I am a lab, you can say, a lab in charge in my university, big data analytics and web intelligence lab. Various students of different states, as well as various, you can say, country, as in New Zealand and Japan and South Africa, they also shared very valuable and significant research in my lab. And we are trying, we can say, we can we should work as a, you can, as a bridge between all these countries. So there are various, various areas in which we can think with the help of AI. Robotic surgery, medical image analysis, drug discovery, medical diagnosis, medical data security, risk prediction, clinical trials, and virtual nursing assistants. I am working with various doctors, those who are working in COVID-19 data. So we have a large amount of data for COVID-19 as well as cancer patients' data. So we have, you can say, accessibility of various type of data. So we can think of, we can do image analysis, we can do drug discovery, we can do medical diagnosis,
Dear participants, we have some technical problems. We lost our speaker, but I believe we will back soon. We should wait a minute. Our technicians prompted me that Rahul Kataria unfortunately has problems with connection, so we obliged to go further. Yes, thank you. Our next presenter is from China. Please, Mei-Ling P. You have 12 minutes. The stage is yours.
Thank you. Yeah, I hope there is some AI can save my former speaker's back pretty soon. Hello everyone, this is Mei-Ling from China. It's my pleasure today to share with you all the young scientists from BRICS countries about Didi's experience and endeavors in the applications of AI-related technologies in transportation sectors. I was particularly thrilled to see that our host asked a question about how do we see the commercializations of our AI technologies. So today, from my slightly different background with you all, I'm from my private companies. I hope that we can find some chemistries between the business community and our academia. So some words about our company. And DD, we are a world-leading app-based transportation and convenience platform, headquarters in Beijing, China. And we operate mobility, food, and delivery services in 10 countries, including Brazil, China, Russia. And we have 550 million users globally. And in 2019, and DD completed 10 billion trips globally. And what makes DD researchers unique is that we have probably one of the world's most complicated application scenarios of AIs. So as you can see in our AI ecosystems, we adapt AI technology and related technologies in smart transportation, smart vehicles, intelligent operation, and mapping, intelligent customer services, safety, and also our AI for social good responsibility. And for example, in our intelligent operations, we do intelligent dispatching, demand forecasting, and for which our project on ride-hailing order dispatching via reinforcement learning won the Daniel H. Wagner Prize at the 2019 Informs annual meeting. And we also do intelligent customer services, which includes online customer service and text data and speech data and user behaviors analysis. And also, which also include translations. So we offer auto in-app translation on apps. So for which we won the third place at the Machine Translation 2020, held by the Association for Computational Linguistics. Every day we receive more than 40 billion routing requests and more than 15 billion location points. So which generates more than 4,800 terabytes of data daily. So you can, the map in front of you shows the request we received in the city of Mexico within 24 hours. So you can see it gets much redder and hotter during rush hours. And we believe that ride-sharing marketplace is much more demanding technology-wise than just playing. For a single ride-hailing order, we need AI and to empower us to manage supply and demand pre-order, anomaly during trip, and also on trip, and to make sure that both our drivers and passengers are safe, and make sure that a driver is who he says he is, instead of an AI face, and control dangerous driving behaviors such as fatigue driving or distractions. So with AI, we have reduced our mean absolute percentage area from 11%, which is 5% less than the industry average within only 4 years. AI can also help us do more with mapping. I'll show you a demo of Beijing Capital International Airport, one of the busiest airports in the world. It's always been a headache for our riders to meet their drivers, especially for someone with a terrible sense of direction like me. So we applied the augmented reality technologies, and so in the right, you can see there's this is an AR map on our app, on our DD apps with optimized pickup points. And so basically, we believe that AI can enable, like help empower the smart transportation, which is intelligent, connected, smart vehicle, which are like electronic and intelligent, and shared mobility. Of course, it will be customized and shared. I'll give you an example. This is the smart traffic signaling system. So the traditional traffic system is set at a fixed interval of like 10 or 20 seconds, no matter it is congested or there's like no one single car. So by applying our smart signaling systems, it is a software-based solutions. We use the floating vehicle data from GPS and gyroscope on our app. We were able to monitoring and analyze and eventually optimize the traffic signaling systems. The end result is the congestion time is cut by 20%. So another very promising field to apply the like AI is autonomous driving, of course. And so we are very proud that we are now developing level 4 autonomous driving technologies on our platforms. And we have, which is say the most ready commercialized scenes for autonomous driving. It's a good news that since this March, if you are in Shanghai city in China, you will be able to hail a robot taxi on DD apps. Of course, if a autonomous vehicle will be sent or it will be like normal vehicles by human drivers, it depends on the solutions we gave based on the weather and road conditions. So like overall, we integrated the above mentioned capacities into this DD Smart Mobility open platforms. As you can see from the inner circle, we basically did, this is our AI infrastructures, our open service capacities, and mobility as a service capacities. So we offer those fundamental capacities to the like all the players along our like the value chain, entire value chain of our business. And for example, for academias, we have this DD Gaia Open Dataset initiative. On it, you can find trajectory like data, travel time index in several cities of China, like industry's most used evaluation index of urban congestion level, and large-scale driving video data set from our dash cameras. So it is open to like academia globally. And if no matter you are from a AI or computer science background or social science background, you will find the data that will be applied, find useful to your research. And I'm very happy to announce that our latest partner is Innopolis University in Russia, our latest, newest market by like so far. So to sum up, we believe that the business community has a bigger role to play in empowering the young scientists and also to offer our mobility, like talent, mobility, and entrepreneurship programs. So that is why we started our DD Engine, our global digital innovators initiative since last year. So we were happy to partner up with University of São Paulo and University of Campinas. So hopefully in the future, we can work with more leading universities globally. And we hope that we can keep speeding up the applications of all those cool cutting edge technologies, breakthroughs that you guys are working so hard on. And in the future together, we believe we can redefine transportation. Thank you all.
Yes, thank you. I think my voice is audible. Yes. So I'm sorry that net was disconnected. Uh, in the last slide, I was discussed that how the AI and COVID-19 are, you can say they are the how AI can be helpful to recognize and identify the patients. So still, is a you can say research is going on, and we are also uh, working in this particular hardware, that how we can use these smart devices such as Fitbit and Apple and other, and how we plan so that they can synchronize the data uh, and give a flash information to the doctor and the patient. And also we are working on some wearable devices. So these are the some concepts which I'm giving you. So this is my latest publication, which is published in Journal of Biomedical Informatics. And in this paper, we and other factors are helpful to analyze the social behavior of the different people which are available on the Twitter datasets. So this is the paper you can check, and these are my you can say in this conclave regard some top publication in artificial intelligence, and you can see some of the work in the as one of my friend in last to last presentation suggested that AI is applicable in everywhere. So that's why, yes, I'm true. And I supported him. That definitely, you can see my different publications in different areas. You can see the social networks and the recommender systems and the music recommender systems. And we are also working in the healthcare. So just I put some my major people. And this is my last slide, and you can see the first photo is in Tokyo, and I'm analyzing some you can say microbes. This the second one in the orange. These four guys are in the Dunedin, New Zealand, and I applied some hardware and big data analytics plus the AI to predict the earthquake in the Queenstown, New Zealand. And this is these are the scientists and the geologists and the professors. And the top the third one is the images of this one. This image, the top right one is the robot in the Tokyo. Another, I have another picture, but still, this is good because the robot can sense some feelings, you can say, of the human. And fourth one, I got the award in my university that I received from my vice chancellor regarding the, the research award. And fourth one, that flag, India and the New Zealand, and only team from India selected in the New Zealand, and we uh, gave the most you can say prominent solutions to their government, and where we applied the AI in climate change and the healthcare and the earthquake prediction. That was around a 3 week program. So you all my friends, you can collaborate with me. And this is my email address and phone number. And it's now from my side is over. Thank you all.
Am I on?
Yes, 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 yes. Thank you.
Thank you very much
I
for the interesting
yes, yes,
presentation. We have one question
yes,
from Denis Ponomarev, please.
yes.
Oh, now my mic works. Okay, thank you. Yeah, thank you
Okay.
for the exciting presentation. Actually, my question was to Mei-Ling. I raised a hand
Okay.
after the presentation of Mei-Ling. The question is as follows. You said that you collect a great amount of data every day, so a great amount of events. Is it the data which comes only from the mobile app, or you use other sources of data?
Yes, definitely. We are gathering the information from mobile data. You can say mobile devices. Sorry, mobile devices, and we have made some apps from which we are gathering the information. Um,
Right, but as far as I understood, Denise asked Mei-Ling.
Right.
oh,
Mei-Ling,
Yeah,
sorry.
could you please answer? But still,
Sure,
that's
gladly.
fine.
Yeah, thanks.
Thank
But I,
you.
I raised my
but
hand
I,
after the presentation
Thank you,
of
Dr.
Mei-Ling.
Kataria, for your help.
oh,
Yeah, thank you.
thank
I
you,
think that
thank
Dr.
you.
Kateria kind of answered my question as well.
Yes.
And yes, and we have like kind of various source of data, but like since we are app-based platform, so the majority of data definitely comes from the app, and so both from our drivers and the passengers. But of course, if when we gather like data from passengers, we like seek the prior approvals. And another different source is our like in-vehicle dash cam like cameras. So it is not like equipped in our all our vehicles, but a large amount of vehicles here in China, because we have a longer histories of operations in China, like for more than almost 8 years now. So we are like commercially or business modely, we are more mature and ready. And so like over the process, we found out that if we are able to collect and say like a visual image, like both from our drivers, which is like inside cameras, and also outside cameras facing the road conditions, which will not only get us like a more, say, comprehensive data set, but also we will able to keep do a better job to keep the drivers safer and passengers safer, and which also conveniently help us to have more data on the road conditions. So which that really facilitated of our development in our autonomous vehicle like solutions. Yeah.
Okay, thank you. We have one more question from Abhinav
Okay.
Sharma, please.
My question is to Dr. Kataria. Am I audible,
Yes.
sir?
Yes. Yes.
Dr. Kataria, what are you exactly working on that robotic surgery you mentioned in your presentation?
Basically, we have started collaboration with the doctors, and we are working on the some of the devices, and we are also planning to do some patents. And if you want, then I will definitely disclose the information because the research is in progress.
Okay, I understand. Yeah,
Thank you
thank you.
for
Yes, thank you.
answering.
And yes, and I also one message I want to say that I have made a WhatsApp group to all of my friends of AI, and then you can please join. Thank you.
Right. Thank you very much. Dear friends, so we should also hear from South Africa. Our final presenter before the interruption is Hercules Cambring. Stage is yours. Please, 12 minutes.
Yeah, I'm going to try my absolute best to make it as short as possible because I think the discussions are just so powerful. It's very interesting from where I'm sitting because I have cited a few of the people in this conversation, which is interesting because I'm familiar with a lot of work that people do in the field of recommender systems as well as AI in certain applications in medicine as well as in neuroscience. But I'm just going to add a little bit of a different spin to it, which one of the speakers earlier on today touched on, which is very interesting, and that is the social science incorporation of this work. So let me just make this to the point. My name is Hakilas. This work is a combination of work that comes from my PhD, and I work very closely with Dr. Vukosi Marivate and Professor Benjamin Rossman in applied mathematics and computer science. And then this work forms part of the data science for social impact group that is led by Dr. Vukosi Marivate. The main idea behind this work is to answer this equation. The equation is, if we can predict which students are at risk of failing and we can choose a correct intervention for them, then we can prevent the student from failing. Well, this is what we're trying to answer anyway. And we're not 100% sure if this approach is the best thing, but when we started, we thought that there are a few applications in the computer science domain that could address these questions or this problem. So there's a lot of literature that has been written about predicting students who are at risk of failing, from using learning analytics through to student performance predictions, and it's done with a relatively high, I say relatively because it depends on the context, of course, but it is done with a relatively high sense of accuracy, depending on where in the world you are and depending on how well you have information about your students, about the system, and about what it is that you're trying to do. Another leg of this work has to do with choosing the correct intervention. So on the one hand, we have this idea that you are trying to predict risk, but on the other hand, you have this idea that you're trying to choose the correct intervention. So what do you do if a student is at risk of failing, or what do you do when someone is in some form of distress within a certain domain? And so we started with a few experiments, and collecting data for these experiments was challenging because firstly, we are in the South African context where we have multiple cultures and socioeconomically, multiple differences within the cultures. Specifically, this idea where you have very underprivileged students that need a lot of support, this idea of equity and how important equity is. And so it is not possible to generalize in our context because you will immediately marginalize groups, and that was not an option. So finding the right data was very difficult, and I'll talk about this a little bit later on. Another issue was we wanted to prepare this information, and our initial strategy was, well, we can create some kind of a recommender system, and if we create a recommender system, then we can recommend what kind of intervention it is, and then it should work. And so we did the experiment, and it turned out to be a very bad idea. We were generalizing people because we were using collaborative approaches within the recommender system that generalized a lot of ideas around the items. It would be detrimental if you recommend medical advice for someone who needs administrative support, or recommend administrative support for someone who needs a psychosocial intervention. And so then it started becoming a very complex question where we realized that predicting students who are at risk is one end of the story, but a bigger part of the story is choosing the correct intervention. Turns out choosing an intervention for a student is just as complex as choosing a medical diagnosis, because you deal with psychosocial, societal, and humanistic issues that lie within society. So the theories that we used to base everything on ended up becoming exponentially more complex overnight, drawing from things like complexity theory, where we're trying to understand the relationship between different systems. Then came a series of issues that we're still trying to grapple with, and that we are continuously working with, but that ended up resulting in a similar situation to this, where we have some information about our students and then certain events. And we realized that these events and evaluating these events had to happen from people. People needed to interact with these events. So you have the student-centered approach, but then an academic-centered evaluation of sorts. Think about it from a lecturer's point of view or an academic advisor's point of view. Student does something, system recommends something to the student, but an academic or a human being evaluates this. And this particular approach lends itself to reinforcement learning, in the sense that we could have a recommender system that gives some kind of low in signal so that you don't sit with a cold start problem. But you require a lot of domain-specific context. And what we're currently doing is we're literally going through NATs, DQNs, SASAs, and DDPGs to see which one of these types of interventions work better. On the one hand, DQN, when you have Q learning optimization, works really well for this similar type of problem, except to finish all your episodes might take 35 years. So perhaps this is not the best, sort of approach, but it is definitely an idea to tease out. On the other hand, when you have DDPGs, actor critique architecture is very important, but defining that architecture is very hard. And so we sit with these challenges. But the point is, what we've fundamentally found throughout a lot of engagements and in a lot of scholarship, not so much from the machine learning and engineering side of things, but from the humanistic side of things and the social science side of things, is that people feel more comfortable if there's human input, despite the fact that there are biases, despite the fact that if a human trains a machine in this context, it might train it incorrectly with some terrible ideologies. People are more comfortable with that than they are with the system generating its own ideas. So this has to be factored in, and that's an idea that we are teasing out and playing around with. And this gives you two sort of elements: a system-generated type of recommendation or intervention, and then a human machine-generated intervention where the recommendation from the system is then evaluated on human feedback, which feed into either some kind of a reward function or feeds into optimizing an optimization function. But the point is, it's some kind of reinforcement function that feeds itself into this problem. So what we learned from all of this up until this point is that we need to know something about the student, we need to know something about what they do, we need to know something about how they interact with the institution and something about the institution itself. But we also need to understand that human agent interactions are very important, and we need to know to what extent these technologies can assist institutions and, more importantly, students, because a lot of the feedback is supposed to be human-machine generated, human-human generated, and machine-only generated, and those three paradigms we are comparing to each other. What we do know is we do not know the extent of this problem and how to solve it yet at all. And we also don't know if this approach can solve the problem, but what we do know is that if we try to solve this problem in isolation, then it won't work very well. So the next step is very logical and very straightforward for us. And I have to be a human being on this one. Fall in love with struggling. I cannot tell you how many times I've been in the fetal position in the shower crying because I'm trying to solve some of these problems. Turns out it's very hard to quantify human beings. Quantifying human beings is difficult. It's a serious problem to solve. But it's a fun one to solve because there are certain things that fundamentally are human and certain things that fundamentally are systems related, cultural related. And you can quantify some of these things. And I think it's fun, learning more about the human race as a whole. Another very interesting thing is that these are behavioral problems. So they are applicable to other sectors of society. And I think this is the important point when I raise this, and I'm almost finished. Is that these are behavioral problems that are applicable to other sectors of society. So for example, patient care decision-making within healthcare. The healthcare problem, i.e., and there've been a few presentations very detailed around how complex it is to solve the healthcare problem, but the human approach to it. So how do you get a human-centered decision-making problem in addition to this? So how do you make decisions on patient care, bedside manner, things like this? Education and higher education-based support strategies. Can systems in university really assist the scalability of psychosocial support? Is that even possible? And then also areas that require human-to-human interaction spaces, such as classrooms, training rooms, entertainment rooms. If you think about sales, can you create this same approach to have an agent sell something to a human being? If you augment NLP to it, and look, it would be very complex, but the point is, this is the decision-making driver behind it. And then lastly, human resource processes in businesses and companies that can drive machine interactions in a more humanistic kind of way. What we're trying to do is optimize human behavior, but at the end of the day, what I think is actually happening with this is we're trying to add human decision-making as an augmented approach into these different algorithms. So I just want to thank the Data Science for Social Impact Research Group and BRICS and ASAF as well. And that's it. Thanks.
Thank you very much for the interesting presentation. Now we can open the discussion. Please raise your hands through the chat. And please, Anton Dolganov.
Yes, I have a question to last presenter. Thank you for presentation. In our university, there are some similar studies. And do you have some, maybe, can you share some interesting results that surprised you? Because, for example, when our team analyzed it, they found that students from dormitory are less likely to have problems because they are more motivated. So do you have something like that?
Absolutely, and thank you so much, Professor Anton. I think it's some of the, I'm familiar with your work as well, but something very interesting that we discovered about this approach, and I just fundamentally from a methodological perspective want to post this to the group at large, is we are finding that you can, through systems like this, identify societal issues that aren't as pronounced, but that have a major impact on society. So for example, the issue of hunger. One of the things that we picked up in these studies is that we have a group of students who are hungry, who actually have hunger and food security issues. And those students inherently are more at risk than the students who don't. And that speaks to a whole sociological inequality issue within our context. So these systems pronounce some of these unique things. Another thing that we're finding, exactly as you say, students in dormitories tend to be more engaged with the institution than students who are not. So they seem to be plugged into the system in some way, shape or form. So they transition easier into it. So these are some of the things. I can talk about this for days, but I think those are the two main things. I agree with what the finding that you're finding is definitely universal, that your group found. It is applicable to South Africa as well. But other factors like hunger or financial insecurity, those things tend to have a large impact on some students in the African context.
Thank you.
Thank you very much. Any other feedback, please? Raise your hands through the chat. Do you have questions for the last presenter? Or maybe... Okay. Denis Ponomarev, please.
Yes, hi. Well, my question is the following. So even before the corona pandemic, there has been a big interest in online education platforms. Now it's even bigger than ever. I wonder if you are involved in such projects that are related to online education platforms, individual learning trajectories.
Thank you so much. I was unmuted. Yes is the answer. So this is a very, and key word is what you said, the individualized learning. That is the key. It's about personalizing information through online learning. And the easy answer, and I just wanted to make this clear, the easy answer is to use the data that is being routinely collected, like where students click and sort of where their eyes are engaged on the screen and things like that. That's the first obvious set of information. The second layer of information is trying to understand the student context outside of the online learning space and what that means translating into the online learning experience. And through our research, it has actually been found that the environmental factors, so sort of, you know, where I sit and my family dynamics and my socioeconomic status and those kinds of things tend to have a huge impact into the type of engagement I have in an online space. A good example, if you have students who aren't used to working on laptops and they're only used to working on their phones, now you have the corona lockdown and they're supposed to do tasks that they can only quintessentially complete on a computer, but now they do it from their phone. And there's a huge difference between how these students experience the online space and, for example, a student who has a mouse and a keyboard. So yes is the answer, and yes, engaged in research like that. But the unfortunate part is this requires a huge global research sort of community to investigate all of these things. It's not a small or easy task to solve, but thank you.
It would be great to collaborate on that.
Thank you. Our next question is from Inger Fabrice, please.
Thank you. My question is for Leonardo Santos regarding your COVID mobility data. I'm doing some COVID modeling here in South Africa, and we do have some mobility data. It's not public due to privacy. It's just from cell phone network, but due to privacy, they don't want to share it and things like that. So I'm just interested to know what type of mobility data you took advantage of in your research.
Right. So could you please repeat for whom was this very question?
Leonardo Santos, Prof. Leonardo Santos. Have we lost him?
Okay.
I think we've lost him.
Can we reach him? Can we reach him, please?
That's a
Leonardo
don't stress. I'll
Santos.
email him.
Are you here?
I can't see him.
We lost connection with him. Sorry.
Yeah. Okay.
Sorry.
No worries.
Any other questions? Please.
Hi, Carlos. Thank you for your presentation. It's good. I have one question for you. What software tools do you use for recommender system building? Thank you.
Thank you. So that this is the thing. A lot of people emphasize the algorithm, which is important. Absolutely, the computation and mathematics behind is important, but the deployment is just as important. Like that's just so. Currently, as it is, we've tried a few different approaches. I'm not going to go into the deep technical side of it. The first one is we tried an on-prem server that piggybacks off a GPU. And what we use for the deployment is just a Docker Python package. So I believe in our terminal, we used a form of Spider that we put inside a Docker that runs off the GPU with it, which sheds and split the processing on GPU, the storage of the information on the server, on a university space, and the interaction is a web application. So it's very similar to a Streamlit or Flask app in a way, where you have a user front end, and then the back end piggybacking heavily so is done off a GPU. So the software we use for it is primarily Python based, but there are some IT components to it in terms of where we do the computation is differently from where we partition the actual deployment of the front-facing app. I hope that answers your question. If not, we can have a very long technical discussion about this because the type of software that you use is so important. Like people underestimate the importance of that for sure.
Dear participants, it was the last question for our session. Thank you very much for a very interesting presentation and discussion. But right now, we should change our activity to the great science stand-up battle. We will see some promo clip, and after that, you will see this very, very interesting show. I should tell you goodbye. See you tomorrow.
Thank you very much for your report. Now, do we have any questions from Brazil, from Mr. Filio?
No, I have no question. Thank you.
Thank you very much. We do have a question from Russia, from Nina Yanikina. How do you see a project in 5 years?
Okay, so over 5 years, should we get funding for this in the short term to do research?
I wanna feel oppressed without any rest. I wanna see you sing, I wanna see you fight, 'cause you are the real beauty of human rights. Makes my body dance for ya.
Dear friends, welcome to Science Stand-Up Battle. A few words about this activity. The aim of Science Stand-Up Battle is to speak about your current research in a fun and simple manner. The presentations will be held today and tomorrow at 2 p.m. Moscow time. Please make adjustments for your local time. It should only be based on the speaker's personal research, a maximum of 7 and a minimum of 5 minutes per speaker. The winner will be determined by you, by the viewers. Forum participants can vote using the link BRICS-YSF2020.ru/media. So that's the media section of our website, and there is a tab Science Stand Up. You will be able to start voting tomorrow after 6 p.m. Moscow time. That is after noon Brasilia time, 8:30 p.m. New Delhi time, 11 p.m. Beijing time, and 5 p.m. Pretoria time. So make sure you support the speaker that you like. We have quite a few contestants, actually even more than we had expected, including 3 videos from the hosts who are not members of the official Russian delegation, but they volunteered to take part in this stand-up battle, and the organizers granted their request. So no more talking, it's time to watch now. And our first video is from Arthur Henrique Azevedo Gonçalves from Brazil. Please enjoy.
Hi, do you know what graphene-like materials are and how it can be used to treat dye effluents? Today, I'll be briefing you how a magnetic composite would be a good alternative to treat dye pollution. My name is Arthur Azevedo and I'm a master's student from Rio de Janeiro State University in conjunction with National Institute of Technology from Brazil. Brazil has one of the biggest textile industries in the world and is responsible for developing regions and employing almost 17% of the Brazilian workers of manufacturing industry. Therefore, Brazil is one of the biggest organic dye consumers in the world. You can see the other BRICS countries in this graph. However, it is estimated that 50 liters to 100 liters of effluent are generated for each kilogram of produced fabric. One example of a worldwide used organic dye is indigo carmine. Indigo carmine is an anionic dye with an intense blue color, very used for denim fabrication. Despite of its splendid color, indigo carmine can be environmentally harmful. Besides, indigo carmine is associated with many different health problems, such as cancer. This problem becomes worse due to its high stability when disposed in the environment. Therefore, new technologies are required to discolorate textile dye effluents. Now, do you remember the magnetic graphene-like composite I told you opening this video? What if I tell you that we can rapidly discolorate an indigo carmine dye solution with this material? Besides, that we can recover this material with a magnet to be used in the next batch of indigo carmine effluent. Okay, first things first. With each passing year, the term graphene is gaining more interest in the scientific world. But what exactly are graphene-like materials? Well, graphene can be obtained by the graphite exfoliation, and it's known as the thinnest material due to its carbon atom thick. It is defined as a 2D sheet composed by sp2 hybridized carbons in a hexagonal form like a honeycomb. There are the two interesting graphene-like materials, graphene oxide, GO, and reduced graphene oxide, RGO. The first is oxygen-rich, while RGO is obtained by the reduction of these oxygen groups. Okay, you just said nothing to me. Why do all these things matter? It matters because graphene-like materials have excellent electronic, mechanical, and textural properties. Graphene-like materials can form excellent composites with iron oxides, for example. Better yet, Brazil, India, and China are among the countries with the largest reserves of graphite. And why iron oxides? Iron oxides have many interesting properties. Magnetite, for example, is a good semiconductor, it has a good biocompatibility, and it's cheaper than titanium, which is a good photocatalyst, for example. And look what coincidence we have here. Our BRICS countries, most of them are iron abundant. That said, the objective in this work was to synthesize magnetic iron oxide particles anchored on RGO sheets, turning this material composite to discolorate indigo carmine dye solution, which is a widely used organic dye in the world. This is possible due to a process known by photophantom process, which generates hydroxyl radicals to attack indigo carmine dye molecule, producing water, CO2, and mineral acids. It is much better for the environment, isn't it? And after all this happened, we still can easily recover the catalyst by approximating a magnet. In this figure, you can see the reactor we used to evaluate the indigo carmine dye discoloration. You can also see here that we used a UV lamp to simulate UV radiation to activate the photocatalyst. Also, we used a ejected reactor to maintain the room temperature. Each liquid we took was analyzed in a UV spectrometer to observe the indigo carmine discoloration. Now, let's jump into our results. X-ray diffraction patterns show that graphite, GO, and RGO are carbon materials, but they are completely different. X-ray diffraction also shows that magnetite particles were formed on RGO sheets. You can see here all these peaks related to magnetite. You can also see this in microscopic analysis. RGO shows a compacted sheet morphology, while the composite has the magnetite particles on RGO sheets. Furthermore, after we synthesized the material, we approximated a magnetic bar to the composite and we observed that the composite was magnetic. This graph here shows the indigo carmine dye discoloration in function of time. We can note that with 5 minutes of reaction, our composite discolorated 100% of indigo carmine dye solution. After the first reaction, we recovered the catalyst with a magnet and reused it in the second cycle. Once again, 5 minutes of reaction were enough to discolorate the indigo carmine dye solution. X-ray photoelectron spectroscopy, which is a surface analysis technique, shows that we have a iron 3 plus, iron 2 plus ratio of 1.9, which means that magnetite particles were preserved even after the first cycle. The excellent performance of this composite can be attributed to the composite narrow band gap. A narrow band gap means that we have an excellent electromobility, which is the key factor for a good photocatalyst. Here's a short video showing that with a simple magnetic bar, we can easily separate our composite from the medium. In conclusion, our results showed that magnetite particles anchored on graphene-like materials would be a promising alternative for the dyeing remediation. Furthermore, our countries are graphite and iron abundant. We can use that in our advantage. So, I hope you guys have enjoyed this video. And when the situation is over, I hope to see you guys here in Brazil. Thank you very much and muito obrigado.
Muito obrigado, Arthur. And now it's time to watch a video from South Africa, from Luis Botha.
Well, hello there. I will be giving a brief introduction into greenhouse gases and how green energy solutions can eliminate the production of greenhouse gases. The population is increasing rapidly. And to keep up with this rapid growth, energy production, industrial production, and transportation has to keep up. This leads to an increase in the production of greenhouse gases and pollution. Now, how does greenhouse gases cause global warming, you say? Greenhouse gases form a dense layer around the planet. Normally, the solar radiation from the sun is reflected back into space. However, due to the dense layer of greenhouse gases, the solar radiation is not reflected into space, but instead gets re-emitted back onto the planet's surface. This causes global warming and climate change. The adverse effects that climate change has on the planet is more notable from observation of nature. One noticeable effect concerns the oceans. In the figure, the increase of pH level in the oceans results in the death of coral reefs. It's important to notice that coral reefs are responsible for housing numerous marine life and oceanic plankton, who are the major producers of oxygen in our atmosphere. The simplest solution to reduce greenhouse gases is by switching over to green energy. Green energy is energy obtained from renewable sources such as solar energy, wind energy, and hydrogen fuel. In hydrogen fuel, water is split into hydrogen and oxygen using electricity, where oxygen is then released into the atmosphere and hydrogen is stored as a fuel. This is conducted by using electrolyzers. On the other hand, energy can be obtained by recombining the hydrogen and the oxygen to form water. This is done using fuel cells. In a fuel cell, as you can see, the hydrogen loses its electron. The electron moves from the anode all the way to the cathode, where it forms with the oxygen and then combines with the hydrogen that is present to form water. However, these fuel cells and electrolyzers are hindered by a large overpotential which is required for the reaction to occur. Not only that, the reaction is also hindered by slow reaction kinetics. To overcome this, electrocatalysis is required, which speeds up the reaction and lowers the overpotentials. Now, in order to overcome these hindrances, a suitable electrocatalyst is required. A suitable electrocatalyst can be designed by using properties of a primary metal, such as platinum, enhancing it with a secondary metal, such as nickel, to make electrocatalyst. Now, these electrocatalysts can then be fine-tuned to be used for other fuel cells, electrolyzers, or both, if it's correctly fine-tuned. There are two types of research that can be performed to get the results. One is from experimental research. Second is from theoretical research. Experimental is using a laboratory, such as Dexter's laboratory, but theoretical is using complex computer simulations to calculate results. Theoretical research is an ideal type of research for studying various properties of materials due to the advantages of using computer simulations, which allows the researcher to narrow down all the possible types of material required as electrocatalysts. This then enables the experimental chemist to take the results, perform it in a laboratory, and then verify the results to obtain suitable electrocatalysts for either fuel cells, electrocatalysts, or both. Therefore, reaching the goal of green energy can be achieved by collaboration between different types of research. It's not limited to experimental or theoretical. There's all kinds of different research fields that can be used. But this is the end of my slide. Thank you very much for listening and have a wonderful day. Goodbye.
Thank you very much, Louise. Thank you. We enjoyed your animations. And our next video is from India, from Sandeep Samvanshi.
Hey, hi. How are you? Why are you looking so nervous?
Hi. I just came from hospital. Doctor told me that I have a cancer.
Oh, but don't be nervous. Nowadays technology is so advanced. So it can be cured.
Yeah. Doctor told me that it can be cured with radiotherapy. But I know it's a lengthy and costly process. Also, it has many side effects such as sickness, hair loss, eye irritation, skin problem, etc.
Yeah, that's true. Radiotherapy has some limitations in cancer treatment. But what about cooking cancer with magnetic nanoparticles and hyperthermia?
What? I didn't understand.
I am talking about magnetic fluid hyperthermia therapy. It is an advanced method based on nanotechnology which has emerged as one of the promising methods for cancer treatment. I am working on this method at my university lab.
Looks interesting to hear. Can you please elaborate it for me?
Yeah. Why not? Basically, in this therapy, magnetic nanoparticles are introduced into the tumor, and then they provide the thermotherapy.
What? Did you say thermotherapy?
Yes. The thermotherapy raises the temperature of the tumor cell while keeping the surrounding healthy tissues at a lower degree of body.
But how these nanoparticles generate the heat?
If we put a magnet near the nanoparticles, they will line up with the magnet. If we want the nanoparticles to move, we can move the magnet and the nanoparticles will follow. If we want the nanoparticles to move quickly, we can use an alternating magnetic field. The nanoparticles follow the magnetic field and move to always align with it. If the alternating magnetic field moves quickly, so will the nanoparticles. When they move quickly, they start getting hotter and hotter. If they are in the body, this can increase the temperature of the cancer tissue around the nanoparticle, which is called hyperthermia. This can be helpful in treating cancer. Let's look at an example. This boy has a tumor, but doctors are going to help him by using magnetic nanoparticle therapy. First, the doctor injects the nanoparticles directly into the tumor. Since the nanoparticles are really small, they move randomly around the cells. Now the doctor puts the tumor in an alternating magnetic field. This makes the nanoparticles move very quickly, and if they move quickly, they will start to get hot. Really hot. The temperature can get so hot that the nanoparticles start to hurt the bad cells, and the tumor can shrink over time.
Oh, I see. You use the magnetic fluids to induce the hyperthermia that raises the tumor temperature.
You were right. We use magnetic fluids. It is a liquid that becomes strongly magnetized in the presence of magnetic field.
You said magnetic nanofluid contains magnetic nanoparticles. So the magnetic nanoparticles, each billionth of a meter in size, can seep into the tissue of the tumor cell.
Yes, this is due to the high permeability of these vessels. Magnetic nanoparticles are really small particles about 1,000 times smaller than a single cell. Thus it is possible to magnetically target these fluids to cancerous tissues intravenously.
Oh. And afterwards these magnetic nanoparticles can be heated by exposing the tumor to an alternating magnetic field.
Yes. This causes the tissue's death by heating. The process is called magnetic fluid hyperthermia.
Which you call thermotherapy.
Exactly. Temperatures in the range of 41 to 45 degrees Celsius are enough to slow or halt the growth of cancerous tissue.
However, these temperatures also destroy healthy cells. So this is your challenge, to use hyperthermia treatment to increase the temperature of tumor cells for about 30 minutes.
Yes. And yet maintain the healthy tissue temperature below 41 degrees Celsius. We also have to pick the right material for the nanoparticles.
Ah. So what material do you choose? Because platinum and nickel can be toxic.
This is really a good question. We are using biocompatible iron oxide nanoparticles, which are highly stable and responsive to magnetic field. When we send the nanoparticles into the body, we need to add a coating. It's like a hard shell coating that covers the particles. The coating helps the nanoparticle work correctly without hurting any other healthy cells. If you put a bunch of nanoparticles in your body without a coating, they could all clump together. This would be bad because they could clog an area in your body and not get to the right place. So we add coatings. We need to pick the right kind of coating that help the nanoparticles go to a specific part of the body. In our recent work, we have shown that coating of the nanoparticles enhances the biocompatibility to better extent.
Fascinating. Is this method currently available in the market for treatment?
No. The method is under clinical trials, and hopefully it will be approved very soon.
Thank you very much. I am so glad to have a discussion about this with you. I hope this method will be approved very soon.
Yeah. Hope so. See you soon. Take care. Bye. The global cancer burden is significant and increasing day by day. According to World Health Organization, the cancer burden is estimated to have risen to 18.1 million new cases and 9.6 million deaths in 2018. Predictions suggest that by 2040, there will be more than 29.4 new cases each year. Cancer productivity losses due to cancer disease are one of the major concerns of the BRICS countries, and it highlights the need for advanced diagnosis and treatment modalities through the development of multifunctional nanomaterials that allow for point-of-care engineering. By eliminating the need for highly specific and costly equipment, this class of diagnostic and therapeutic materials can be easily implemented in the BRICS countries, which could have a massive impact, not just on the health of individuals, but also at economic level. So, let us come together and fight with cancer. Thank you.
Thank you very much, Sandeep. And we have one more video from India. This time it's from Prasenjit Ghosh.
Hello everyone, welcome to my presentation. I am Dr. Prasenjit Ghosh. I have recently completed my PhD from Indian Institute of Technology, Bombay, India. I am a BRICS Young Scientist Fellow, and in today's Science Stand-Up contest, I will be talking about human waste, its concerns and treatment challenges. This is a broad research area and I work on a particular field that I will discuss subsequently. On daily basis, an adult human produces about 100 to 250 grams of feces and 600 ml to 2.6 liter of urine. Feces contains 75% water and 25% solids, whereas urine contains 94% water and remaining solids. It takes about 12 hours to convert food into feces in the 30 feet long gastrointestinal tract in the human body and 9 to 10 hours to produce 2 cups. Now I will discuss what is sewage. It is a mixture of human wastes along with sanitary items, toilet papers, pads and diapers, other waste residues and huge amount of water. There are two important terms, black water and grey water. The black water contains human feces and urine mostly. Grey water contains wastewater generated from wash basins, bathroom sinks, bathtubs, washing machines, etc. Black water contains fecal solids and urine solids, which is huge if we consider waste generated by a community on a daily basis. Hence, we should see poops and urine everywhere but we don't. Why? Because it gets treated by sewage treatment plants constructed all over the world. Now, why treatment is required at all? Because human feces can contain diarrhea, cholera, typhoid, hepatitis A causing microbes that can contaminate drinking water if disposed untreated, and it can also contaminate crops if these are grown by sewage irrigation. Poor treatment conditions contributes to 10% of the total disease burden worldwide. This pie chart shows the fate of freshwater withdrawals for various purposes worldwide. It can be seen that 8% of consumed freshwater leads to sewage generation. It is worthwhile to mention here that 24% of globally generated sewage is contributed by the BRICS countries only. With respect to Indian scenario, 78% of sewage remains untreated, which is a major concern. So, what are the usage options of feces and urine? While human feces can be used to produce fertilizer and biogas, aged and recycled urine can also act as fertilizer. But treatment is important before such uses. Various treatment options are available, such as chemical, thermal, physical separation, and biological treatment. Biological processes have been found more effective with recovery options of valuable products such as methane, which is a biogas, biofuel, and fertilizer. Human feces has significant economic value. It can produce around $9.5 billion worth fuel, and methane produced from it can generate enough electricity for 18 million households. Various measures have been undertaken to improve sewage treatment worldwide, such as Sustainable Development Goals, which were set by various water regulatory agencies to improve the water quality by the year 2030. In India, Swachh Bharat mission was undertaken, which began with toilet construction as its major focus. Treatment innovations have also been made, which include production of poop briquettes, which has similar energy content as of coal. Innovation of bioelectric toilets have been made that use treated sewage for flushing toilets and at the same time harvesting power from treatment to illuminate bulbs, which can be used at night. One major implementation of innovative treatment was made in the form of bio toilets in Indian trains, with an aim to create a discharge-free green corridor wherever Indian railway runs. Earlier, what used to happen, suppose you are crossing a road which has a overhead railway bridge and a train is passing at the same time, and suddenly you feel something smelly on your head. By the time you realize, you are on social media. The railway tracks also used to remain very dirty with various colorful poops. Open defecation of human feces has reduced significantly over time due to such innovative implementation. However, there are some treatment challenges. Widely varying solid content in sewage and its composition often reduces the effectiveness of its treatment in the sewage treatment plants. The combined waste stream of feces and urine is also a major problem for treating. Bioelectric toilets are less power efficient. It is difficult to illuminate bulbs of high wattages. The social acceptance of biotoilets is also a major hurdle towards its implementation in India. Antibiotics get released into the environment through human feces and they lands in water bodies from treated sewage disposed by sewage treatment plants. Certain microbes are evolved that are often immune against multiple drugs. It is a cause of serious concern. This is, however, the proposed field of my research. According to a recent research done in China, fecal matter plumes generated during toilet flushing could spread COVID-19. Hence, it is a new challenge to the scientists. Now you can see the picture of a dog which has just pooped and is thoughtful about the fate of its poops. Thank you.
Well, thank you very much. It's an unusual view of this topic. And one more video from India, from Anupma Thakur.
Hello everyone. People call me Smoky and I love it though. Reason is simple. I make this environment smoking hot. I think of engines in an earth state of mind. Behind the walls of these engines, life is defined. It's all about airborne particles and liquid particulates, oxides of nitrogen, sulfur and carbon. Yo, I'm smoking in an earth state of mind. Cars, scooters and planes are my favorite. And love for you people is always great. Straight out from the hot dungeons of this nature, I'm able to raise the temperature by 1 degree. Yo, I'm smoking in an earth state of mind. To put up a fight against ozone, I never thought I would see that train. Crazy, quiet and beautiful like a plane. When I was young, my enemy had a chain. I was kicked out and without any disdain. Now it's time. I'm gonna move your son. Yo, it's Smoky in an earth state of mind. But there's a deja vu. Like there's a slippery light, quite a bite. I can't take that fatty researcher. I can't take that hydrogen anymore. Damn! This smoky dream again. I'm sick of it. This smoky anthem is really troubling me a lot. People think of their favorite foods, adventurous places, and even new adventures like paragliding. But I think of the smoky and hydrogen all the time. Yes, I'm talking about hydrogen, the greatest weapon that we have in our armory. This hydrogen can not only defeat smoky, but also provide us with the clean future fuel. Yes, come on, I'll show you how this actually happens. This is the photoelectrochemical cell in which the water is getting split into hydrogen and oxygen in the presence of the solar light. Now, I will briefly explain by telling a tale of two friends. Those are photons and the cunning anode, who are very jealous of the strong chemical friendship bond that exists between the oxygen and hydrogen molecule of water. Now, this very smart and cunning anode plans a conspiracy in which it utilizes the photons, which are basically the carrier of electromagnetic energy from the sun. So when these photons falls at the surface of this anode, the electron hole pair formation takes place. And then this anode, without wasting any time, surpasses all these electrons via super fast tunnel to this cathode. And then the holes which are left behind at the surface of this electrode participate in water oxidation reaction. And this hydrogen here has a strong and passionate love towards electrons, gets attracted to the cathode, and the oxygen ion, which does not at all like electrons, stay back at the anode and combines with holes to produce oxygen gas at the surface of this electrode. While the hydrogen ions which are formed gets collected at the cathode, attains all these electrons and form hydrogen molecule as a product at this electrode. Now this basic principle solves as the mechanism for photoelectrochemical cells being used today. And now the actual question is that will these oxygen and hydrogen ion ever meet again? Will they form water again? And the answer to this question is yes, they will one day definitely meet when we will utilize the stored hydrogen as a carrier, as a fuel, as a clean fuel in vehicles. And when this hydrogen will be used as fuel, it will combine with the oxygen molecule from the air to form water as a product and produce huge amount of energy. And this hydrogen is the only solution that we have to kill and destroy the evil objectives of smoking. And now let's salute to the long lost friendship of this hydrogen and oxygen. At the end, I would like to say thank you. I'm Anupama Thakur, the faculty researcher, signing off.
Well, thank you very much, Smokey. That was fun. Our next video is from China, and it's from Wan Hansang.
Hi, I'm Han Yang from GI. GI is a technology company headquartered in Beijing, and we are focusing on AI, including computer vision, and we are also making fully autonomous drones. Today, I will show you a short documentary about how we are helping one of the largest Chinese animal conservation group, CFCA, to protect the Chinese south leopard in Shanxi province. Please enjoy.
华北豹是唯一只生活在中国的一种豹子，我们是它们在这个星球上唯一的邻居。野外的华北豹现在已经非常稀少，我们最不希望的就是这种美丽的豹子，像华南虎一样在野外消失。我们这个团队叫猫盟。 是一个中国本土的这个野生动物保护的机构。那么我们在山西这个地方呢，在这儿已经来了，断断续续来了有10年了吧。他那边相机就在这儿。你看这个拍的是个狗獾。我们从13年到14年，就是我们的队员加上北京师范大学的这个科学家，我们一起在这儿工作。当时有4、5个人吧，大概花了有整整1年的时间吧，布置了大概200多平方公里的这个范围啊。当时相机大概已经布下去70、80台吧，一直到2018年，现在是接近500平方公里的这个监测范围。那么相机呢，大概是100台左右。这个就是红外感应器。 这个是触发那一部分是吗？对，这是触发，这是拍摄，这是红外照明。这地方特别亮，你看过来，这地方正好太阳形成一个光斑，形成一个强烈的热对比，所以它就会触发。有时候我们装相机它基本上是没法避免的。一段视频，比如说拍15秒，它一个相机有时候一下子就拍了可能好几百段。所以我们在任何一个地方，我们说我们要监测这儿，至少我们要花半年到1年的时间。 才能把这儿的这个动物的情况基本上做到心中有数。
我以前是做动物行为学研究的，来到猫盟之后呢，有80%的时间大概都花在看数据上面了。先把这数据用电脑一张一张的看，或者是一段视频一段视频的看，看了之后把它按物种分了文件夹，再把它整到Excel表格里面。 然后再计数，计完数之后出图，整个过程差不多，怎么着都得1个星期吧。
我们泛华智能和猫盟合作半年了，但是这半年里面又不知道多少动物就没了，这个，所以在我看来，有一些工作就不应该人去做，比如看照片这种工作，你人的工作应该是放到更宝贵的事情上，比如上山去收集数据。所以我们一直认为这些看照片的工作应该让计算机视觉去做，让电脑自动帮人把这所有工作全部完成。
所以后来就是跟 GI 跟泛华智能的汉阳我们认识了以后，他一说这个，我就觉得特别好。我说这个东西可以极大的解放我们的这个生产力。
所以我们做的就是把基础软件提供给他们，他们基于我们的软件训练出自己合适的模型，来识别他们想要识别的物种。
我现在呢，把我的经验和知识交给电脑，就能够在1、2个小时之内处理过去我需要1个星期才能完成的数据处理这种工作量。
当下凡那边能够更高效地处理完所有的数据，我们也就能够更及时地获取这儿的山里面野生动物它现在的状况。那么这意味着我们的保护会更加高效，我们能够更好地保护这儿的这些野生动物。
Thank you very much. We really enjoyed the nature that you have shown us. We are actually halfway through our videos today. And now it's a video from Russia, from Yevgeny Alexandrov.
Hello everyone, I'm Evgeny Alexandrov from Samara, Russia. And Samara is located in the breast of Russia. Therefore, it can be called the heart of Russia. And the shape of Samara region looks like a heart. Samara is famous by producing rocket engines and by oil industry. Today I want to talk about how artificial intelligence and new materials help us save the planet. You know that greenhouse gas affects the climate change on Earth. For example, it produces greenhouse effect, and this heats up our planet. I think many of you feels the change of climate. For example, this winter in Samara was very snowy, and my daughter was able to dig a cave in snow hills. Another problem is radioactive contamination, which can destroy all life on the Earth. And cancerogens are produced by many industrial companies. These compounds destroy our genes and cause cancer. But what are the solutions of these problems? Maybe we can move to another planet, but I think not in the nearest time. Science gives us very good opportunities for solving these problems. For example, science gives us new sponge-like materials, which were discovered very recently. And these materials have a very perfect order because they are crystalline, and they have also very nice cavities. And these cavities are very small, and at the same time they have very large surface area. 1 gram of such compound, such crystals, can have the surface area equivalent to the football field. Because of these cavities, these materials can capture CO2, which is the main part of greenhouse gas. They also can capture radioactive iodine, and they can capture cancerogens. For example, they can clean up water from dichromated ions in minutes. At the same time, we have very big question. There are so much porous materials, but which of them are the best for given application? And to answer this question, we use special tools, theoretical tools, because it is impossible to synthesize all these materials and check their properties in lab. And we make classification of already known properties of these materials to make prediction of unknown properties. For example, we have a porous material, and this material can have triangular or rectangular pores, and these pores can be constructed by building blocks of different geometry, diagonal, prismatic, square, or octahedron. And many different chemicals can have such geometries. This kind of collaborations compose the knowledge base. Knowledge base is a part of expert system, and expert system have books, brains, and language for communication with user. And user can ask expert system, what is the best material for this kind of application? And expert system can, before answering, it can ask again, what do you mean exactly? What kind of details can you provide me more? For example, what kind of pores do you consider? And so on. And after clarification of these questions, inference engine can produce new hypothetical structures and also give the list of the best materials which are already synthesized before. This is what we do in our research work. We create decision trees, we predict new materials, and make simulation of these materials using our program package installed on the supercomputer. And after this, we go to lab for making synthesis. That's all. Thank you for your attention.
Thank you very much. Just a reminder, tomorrow you'll be able to vote for the ones that you like, for the videos that you like. And now we continue with one more video from Russia, from Ivan Fedosov.
Hello, dear colleagues. My name is Ivan Fedosov. I am a second-year postgraduate at South Ural State University. My area of interest is development of measurement technique and data processing. Today, I will tell you how to determine that you are you. Wait, it's too easy. Today, I will tell you how to determine that you are you if you're not a person, but a measuring device, for example, a temperature sensor. Imagine a situation. You live, walk and feel all symptoms of the disease. You have headache, fever, arms and legs ache. You take your new electronic thermometer, measure your temperature and see 36.6. I don't believe it. You find another electronic thermometer, measure your temperature elsewhere and see 36.5. You don't believe it, shout you. Try to find your old mercury thermometer. It shows 39. Wow, you are sick. To be precise, you confirmed you are you because your electronic thermometer is also sick. Unlike humans, measuring devices or sensors have a strictly defined function to measure flow rate, pressure, or temperature. At the same time, sensors don't have additional sensations. However, like humans, sensors sometimes get sick, and it is very bad because measurement errors come at a price in industry. For example, in 2019, casting industry lost around the world 2% of the volume due to temperature measurement error. Look at this value, $315 million. In addition to economic losses, incorrect measurement of process parameters can lead to technical accidents and human casualties. Our goal is to help sensors to determine their aches and to tell about it. Today, we have focused on temperature sensors, as they take up to 50% of all sensors in industry. Industrial temperature sensors are electronic devices that consist of primary transducer and electronic unit. The primary transducer consists of special selected metals, which properties vary with temperature. The electronic unit digitizes these properties and convert it in temperature. The most common solution for improving reliability of temperature sensors is to duplicate them. To do this, we placed the second temperature sensors near to first one. However, the second sensor doesn't guarantee that it will be able to determine in time that the first sensor is sick. Also, the second sensor may get sick before the first sensor, and moreover, they both may get sick together. How have we led the sensor to tell us more about its state? The first method is similar to work of a fitness tracker. We can trace our pulse continuously by themselves, but we can use fitness tracker for this goal. The main question in this approach is how to find a pulse signal from many other signals of the human body. For example, some fitness tracker can find even cucumber pulse. Trust me, I've checked it. So, in the first option, we add another metal to the primary transducer of the sensor, whose properties also dependent on the temperature. It allows us getting an additional information about sensor. Then we extract information about the state of the sensor by our algorithms, determine the current diagnosis of the sensor, and the remaining time of its trouble-free operation. In another way, we predict the death time of the sensor. The main difficulty of its method is how to extract information from modified sensor design. We have learned to do this. The second method is similar to choose a watermelon, as it happens in Russia. You come to the market, choose a beautiful watermelon, knock on it, and try to hear something. The main questions in this method: where should you knock, on the watermelon or on the head? And how do you interpret the sound heard from watermelon to choose a? Seriously though, it looks like this. We send test current signal to the primary transducer of the sensor and receive a response containing additional information. Then we extract information by our algorithms, determine the current diagnosis of the sensor and the remaining time of trouble-free operation. The main difficulty of this method is how to acquire the response and extract additional information from response. We have learned to do this. Today, our project is 2.5 years old. During this time, we have conducted more than 1,000 hours of testing, and we have developed 2 prototypes that are able to determine their state. In addition, we represent the real demands of industry in our products. We are negotiating with some companies from production aircraft engine components to production of automobile tires. Sensors, they are almost like people, and also they sometimes get sick. Our mission is to help sensors to determine their state and to tell about it. However, our technology is not widespread yet, so if you feel bad and the thermometer shows 36.6, you should consult a doctor. Thanks.
Thank you, Ivan. I hope nobody feels sick. I hope everybody feels fine. And our next video is from India, from Nishant Kumar.
Good morning, everybody. I'm Nishant Kumar, Early Doc Research Fellow at Indian Institute of Technology, Delhi. I am from India, and today I'm going to present my project work. This project work is totally based on the artificial neural network based control techniques, and this control technique has used for the solar PV energy generation system utilization improvement. Means that here the utilization factor of the solar PV energy generations will improve by using this artificial neural network based control technique. In this project, this type of solar network has considered. Means I have used one solar panel for extraction of solar energy from the sun, as well as the generated solar energy we will use for the all the local loads and household loads, and after that all the extra power will be fed to the grid. And in some cases, suppose our load demand is high, on that situations we will take the extra energy from the grid to match the load or local loads. It's like this type of system has considered, but the problem with this system is this network will only use for the 8 to 9 hour, because sun will available only for 8 a.m. to 5 p.m. like this, so it will work mainly for 8 to 9 hours. The question is, what is the use of this entire network during the night time? Means night time means 5 p.m. to 7 p.m. Around 15 to 16 hours, this entire solar network is totally useless. Means that because in night time the power will directly come from the grid and used for all the loads. But what is the use of this solar circuit? Solar circuit in general looks like this. In this circuit, we can see that a solar circuit is consists of 1 or 2 converters. Mainly for we will use 2 converters, means that one converter for the power extraction from the panel and another converter for extracted power conversions into AC. And then because all the our local loads are in general AC in nature, so this DC to AC conversions we use one converter. But question is, this system will work only in the daytime, but in the what is the use of this entire circuit in the night time? In night time, both converter and capacitors and filters and all interfacing inductors all will be useless. Only the power will come through the grid and go to the So we can conclude that the entire solar network or solar system will be useless during the night time, and in night time is around 2/3 of the whole day. So the utilization factor of this entire electrical network or entire solar network will useless for 1/3 of the time. So how we can improve this system, or how we can use this network for some other purpose? This is the key objective of this whole project. So here in this project, I have developed a new technique for operate this electrical network in night time also for some other purpose. Here mainly this network will be used during night time for reactive power generations, because for reactive power generation required only two things. One is a converter, which is here, and another is here the capacitor which is on the DC link. So this capacitor and converter can use in during the night time for reactive power generations. I know during the night solar power will not available, so solar active power generation by using the solar panel is not possible, but this at least some portion of this electrical network can use for some other purpose, and the purpose is reactive power generation during the night time. And we know that all AC loads require two type of energy. So some part of energy is active power and some is reactive power, and both combinedly required for any AC load. So the reactive power will generate by using this network, and the active power only will come from the grid. So both electrical network and grid will fulfill the load demand. So here I can conclude that this network will operate during the night time for reactive power generation, which will support the grid in the terms of reactive power generations. So the burden on the grid will lesser during night for fulfill the reactive power load demand. For that purpose, this control I have developed. In this control, I have used the artificial neural network, which is based on ANOVA kernel least mean square algorithm. And in this control, this neural network techniques mainly for the estimation purpose, and this estimates the active and reactive power requirement of the load, as well as unit temperature generations, which has uses for the synchronization with grid. So this ANOVA kernel here works for two purposes: one for the load power estimation, and another is the grid synchronization. This is the electrical network of this artificial neural network, where I have shown the weight updating process, how this updating process is happening. During this updation process, the data is circulating from input to output side, and as well as input is coming from the load current. This is the entire block diagram of the neural network which I have used. This is totally based on the single layer neurons, and this is the all mathematics in the block format I have shown here. This is the experimental setup which I have used during my testing. What algorithm I have tested for testing purpose. This is the experimental setup on which I have developed. The obtained results are shown here. In these results, we can see that the 1.82 kilowatt power is going into the grid, and the load demand 1.92 kilowatt power is going to the load. And these results I have obtained during the daytime. Here day to night mode of operation is shown, means that during evening time how the system will work, means during the daytime the power PV is generating power, but in night time the PV power is zero, but still the power is coming, means in the night time the power is coming from the grid and going to the load. Here it shows that during the night time the power is coming from the grid, but the reactive power requirement of the load is generated by the grid, our circuit. So this has shown here. But in the daytime, the both reactive power and active power is generated by the electrical network, as a solar network, and the daytime the only generated extra power is going inside the grid. Similar type of result is shown into the night to day mode of operation, means in morning time how the system will operates, means in night the solar power is zero, only the grid power is coming and going to the grid. Similarly here during the night time reactive powers is shown and then going to the grid. Similarly the same operation has shown tested in different type of other conditions also, means the linear load unbalancing conditions, over voltage grid conditions, under voltage grid conditions, as well as the grid voltage unbalanced conditions also I have considered for the testing. And this is also shown that 32% unbalance in the grid voltage, but current is totally balanced, and like this. So that I conclude that the AI based developed technique for the solar is highly suitable, as well as it improves the overall performance of the electrical network, as well as utilization factor of the electrical network also improved by using this AI based control technique. Thank you for your kind attention. Thank you everyone.
Thank you very much, Nishant, for your video. I have information from our technical team. It's a request to all the participants who are presenting tomorrow. Please join 1 hour before the beginning of the forum, because we need to check your presentations, which will take up to 10 minutes. After that, you can leave and join any time. Thank you very much. We have 3 more videos to go today, and this one is from China by Liu Yang.
Hello everyone. Today we are going to briefly introduce a new matrix product named as semi-tensor product of matrix, and how it is applied to the researches of brain networks and gene networks. We firstly see 2 simple examples of matrix product. For example, given matrix A with dimension 2 times 2 and matrix B with dimension 2 times 2, then under the general matrix product, we can obtain its product is this 2 times 2 matrix. However, if matrix B is a row vector, it is not well defined for the matrix product of matrix A and B. So how can we define the matrix product for this example? So let's see what is semi-tensor product of matrix. Semi-tensor product of matrix is defined based on the chronic product of matrix. The chronic product of matrix is defined as this equation in definition 1, which extends the dimension of A and B. Then we see the concept of semi-tensor product of matrix, which is actually the generalization of common matrix product, because under the semi-tensor product of matrix, we can product 2 matrices with arbitrary dimensions. Here we no longer need set n equals p, and we can also see that where n equals p, the semi-tensor product of matrix is actually the well-known general matrix product. For example, given a 3 times 3 matrix A and a 2 times 2 matrix B, it is invisible under general matrix product. However, it is well defined under the semi-tensor product of matrix, and its final product is actually a 6 times 6 matrix. Note that brain networks is a network where nodes are connected with logical operators. For example, the negation operator, conjunction operator, disjunction operator, conditional operator, and the biconditional operator. The detailed truth table for these logical operators are shown in this table. For example, given p equals 1, its negation is 0. Logical function is a function with several x1, x2 to xn, and each logical variables are joined by logical operators like negation, conjunction, and so on. This is a simple example for a logical function with 3 variables pqr. Then, before we learn how to apply the semi-tensor product of matrix to brain networks, we define an equivalence between logical variable 1, 0, and the vectors del2, 1, and del2, 2. This means we define an equivalence for the logical domain to the vector set delta. Under this equivalence, any logical function can be equivalently expressed by an attribute matrix form. Then we can find a unique structure matrix for any logical operators. For example, as for the negation operator, we can find the matrix Mn, and a conjunction operator, we can find matrix Mc, and so on. So the logical expression, we can express it into matrix form. Under the equivalence between the logical expression and its matrix form, we can now study the logical dynamics of brain networks under the matrix form. As for brain networks, by expressing the logical variables using vectors, we can finally express the logical dynamics of brain networks under the matrix form. Xt plus 1 equals to matrix L times Xt. Xt is the semi-tensor product of x1 to xn. And as for Boolean control networks, where some external control inputs are added in Boolean networks, one can also find the matrix form xt plus 1 equals to matrix L times ut times xt. Here, matrix L is called the state transition matrix, describing the whole state space. For example, consider a Boolean network with 3 nodes A, B, C. The logical connection between these nodes are given by these functions. So we can find a unique matrix L with dimension 8 times 8, which uniquely describes the state space, how the logical states update. It is well known that the dynamics of T-cell can be modeled by Boolean networks with 19 nodes. In the research of drug treatments in curing cancers, one needs to regulate the dynamics of T-cell into a stable configuration. Now, let's see how to regulate the dynamics of T-cell using the sub-tensor product of matrix. The T-cell has 9 nodes, and this is a network structure, how the genes are connected with each other. Using control design, we can regulate 15 gene nodes and design the controllers. We can finally regulate T-cell from unstable dynamics to a stable dynamics. See, before control, there are many cycles and fixed points. However, after control, there only exists one fixed point. This control method is very efficient, and we can find how to regulate to a stable dynamic. Recently, many fundamental works have been obtained under the matrix framework xt plus 1 equals matrix L times xt, such as the topics of synchronization, observability, disturbance decoupling, game theory, function perturbation, and so on. These are some fundamental references on the researches of Boolean networks using the sub-tensor product of matrix. In the end, I wish the conference great success and wish all of you success in your work and happiness to your life. And welcome to visiting Zhejiang University, Jinhua, China. Thanks.
Thank you very much. We have one more video from Russia by Sergei Pavlov.
Come here. My name is Sergei, and what do you think this is? It's sugar, yes, but for me it's primarily a crystal. As you may know, crystals are found everywhere around us. For example, precious stones, which we stick in the jewelry, are crystals. Crystals also may be found in phones, computers, telescopes, mechanical watches. Rubies are used for mechanical watches, and this is how untreated ruby that we grew looks like. Material scientists, but we're also partially alchemists. But unlike them, we can create materials with the required properties for science and technology. With rubies and sapphires, for example, we can control color and growth parameters. Color, which is associated with concentration of chromium, determines the mechanical and optical properties. Mechanical properties are extremely important, for example, in watch stones, and optical properties are important in laser technology. Color and size are of course fun and interesting, but our team is interested in more subtle matters. So we have focused our attention on the world's top subject ferrites. Due to their unique crystal structure, they have uniquely high anisotropy, and these materials can be used in microwave electronics. The management of such subtle matters is the top class of material science, and already we have achieved significant success in this field. For the first time in the world, we have achieved 50% substitution of iron atoms with the aluminum while preserving the initial type of crystal structure. So we've got the material with this chemical formula. And already we can vary the ferromagnetic resonance of barium hexaferrite in the more than 100 GHz frequency range. And for the first time in the world, we have created a new type of ferrite with this chemical formula. And we called it the V-type ferrite. All this is possible due to cationic substitution of iron atoms in the hexaferrite structure with aluminum or titanium atoms, with magnetic moments and ionic radiuses different from iron. This ensures that the integral properties of the material can be tuned. For example, substituting just 2 of the 12 iron atoms with aluminum shifts the frequency of ferromagnetic resonance from 50 GHz to 100, while substituting them with titanium lowers the frequency to 5 GHz. All these changes are happening due to differences in size and magnetic moments between iron and replacement cations. The crystal lattice is distorted, and consequently the anisotropy of the crystal changes as well. Also, if you use, for example, thin plates of ferrite single crystal, in addition to the dopant concentration, you can choose the required crystallographic plane and direction, which gives us an additional option for fine material tuning. The material developed by us is promising for creating anechoic chambers for high-precision measurements, composite materials for use in the medicine, and gas sensors. Customizable materials are the future. Customize your materials, create your future.
Well, thank you, Sergey. And we have one more video, the last video for today. It's a different format from the Science Stand-Up, but the guys from Penza State University really wanted to share with you their love for their campus. So please enjoy this video by Sergey Sorokin from Russia.
Dear colleagues and friends from Russia, Brazil, India, China, South Africa and other countries. It's a great honor for me to welcome you all from Russia during this 5th BRICS Young Scientists Forum. My name is Sergey Sorokin, and I am the one of those Russian scientists who are currently working on big data and artificial intelligence. I was born and raised in my hometown called Penza. Even though many of you know only 2 Russian cities, I mean Moscow and St. Petersburg, there are a lot more other interesting cities in Russia, and Penza is one of them. Actually, Penza is a very beautiful city. It is not too far away from Moscow, and I'm very proud to live here. And now we are on Penza State University campus. Penza State University was founded in 1943, and it is the largest university in Penza region. After my 2nd year of studying at Penza State University, I had been invited to one of the best scientific groups in Penza, working on intellectual image processing. I was 19 years old back then, and I had been programming for 2 years by this time. My first supervisor was a full professor named Mikhail Alexandrovich Sherbakov from Penza State University, and I'm really grateful for everything he has done for me. He really had helped me a lot in the beginning of my scientific path. And only now I can fully understand how important the first professor can be. I am sure you will agree with me that science people are very sensitive and vulnerable. That is why they can be easily insulted, and any accident can simply destroy their possible career in science. Nevertheless, let me continue my story. Working really hard day by day, I became a small part of a large scientific community in Russia. And I am really happy to have been working as a scientist from that moment, to have been working with prominent Russian scientists. My scientific interests include deep learning and image processing using machine learning. I am also working with big data, especially how we can correctly use big data for prediction. I am sure we will have a lot of time to discuss this in more detail during our forum. What I would like to underscore is that even in Russian relatively small city, you can do a really good research. I am happy to mention that here in Russia we have practically no restrictions on the access to the internet, and our access to international scientific databases is fully granted. For example, now I am working with my colleagues from Hong Kong University of Science and Technology, and we are doing a great job together. Of course, because of COVID-19, we have to avoid real meetings, and we have to use Skype and other software for communications. But sooner or later, we will definitely find a way to properly cure this disease and to prevent its spreading. But for the meantime, we will do our best as a science community. It looks like our little video journey has come to an end. I hope one day we meet each other in Russia and have a good meal together. I wish you all a successful and productive forum. Thank you very much for your attention and stay safe.
Thank you very much. That was our last video for today. Just a reminder, please vote for the Science Stand-Up performance that you enjoyed most of all in the Media tab at the forum website. You will be able to do so tomorrow starting at 6 p.m. Moscow time. If any of the participants of our forum have not sent in their presentation yet, please do so today. And well, let's call it a day. Thank you very much for your attention. Tomorrow we start as usual at 2 p.m. Moscow time. That means 8 a.m. Brasilia time, 4:30 p.m. New Delhi time, 7 p.m. Beijing time, and 1 p.m. Pretoria time. See you tomorrow.
烧自己，只为照亮你。把我一切都献给你，只要你欢喜。
你让我每个明天都变得有意义。生命虽短，爱你永远不离不弃。
你是我的小呀小苹果，怎么爱你都不嫌多。红红的小脸温暖我的心窝，点亮我生命的火，火火火火火。
你是我的小呀小苹果，就像天边最美的云朵。春天又来到了花儿开满山坡，种下希